Yeah, welcome to GradeUp, which is the largest online education platform for engineering students. Myself, Mallesham Devasana, I'm working as a faculty on GradeUp. And today we are going to look at the session that is all-in-one a master revision class on compiler design. I hope you enjoyed in the previous session. I'm very sorry we got audio problem in beginning of 2 minutes. Okay, let me repeat everything. Yeah, good evening, Jai. Yeah, Manasvi, Shukrut, Rahul, good evening. Ravi, Shekhar, good evening. Yeah, all clear? Rahul, good evening. Abhirup, yeah, I'm sorry guys. Good evening guys. Are you ready? Have you enjoyed in the previous session that we have taken on yesterday? Yeah, I feel that, even I have not completed whole TOC in just 3 hours, but I made it possible because you are very near to the exam. I felt very happy in the previous session. Yes, this session is also going to be similar to the previous one, but compiler is a very easy subject for the exam point of view except 1 or 2 concepts. So that is also I'm going to explain where you face a difficulty and how to handle it. Yeah. Good evening, Arjun. Good evening, Yash. Good evening. Welcome back. Mahmuda, good evening. Yeah, Samir, good evening. Good evening, guys. Yeah, Maruti, good evening. Sweta, good evening. Deepika, Bhupendra, yeah, everyone, good evening. Shristi, right. Okay, so are you ready? Yes. And these sessions are going to make a revision. I'm not going to make a practice. Believe me that whoever learned the compiler design, this is the time to make a revision on compiler so that you will be ready for the exam. I don't want you to waste your time and my time, and I want you to prepare for the GATE exam, that is 2021, so that, yes, Tejas, even my time is also valuable than you, Tejas. Yes, and those people who are feeling slow, please watch offline rather than online. So I recommend to come live because you can ask the doubts. But don't restrict the educator. If you restrict the educator, you lose the concepts. Remember that point. I work for the students, and and any one student is disturbing our class, please take care of them. Yes, everybody? Fine. Yeah, this is about my background. If anybody is joining today, I have 12 years of rich experience in GATE, in offline and online, and also have discussed with so many students personally to guide them, and in all the difficult situations I handled and I have guided, still guiding. Every day I'm learning a lot from the students. And I have secured all year rank 210 and 119 in my BTech, but at the time I had no support of any educators. Today I am working for the students. Only the reason is I know if the student is going to prepare without any guidance, how much time you are going to waste and how many difficulties you face, that I clearly seen on in my preparation. So I want you to guide in the best possible manner. That is the reason I have chosen this platform, and I'm helping you to learn each and every concept in right direction. All right. So my area of expertise in theory of computation, compiler design, and discrete mathematics, programming, data structure, and algorithms. These are my favorite, but and many of the things still I learn every day and I teach. Yeah, good evening, Dhruv, good evening. And exam analysis. If you are attending a morning session and after the exam, immediately come for the analysis that we are going to begin at 12:30 p.m. And as soon as you come out of the exam, you can attend this live session. And those people who are attending at 3 p.m., that is afternoon people, they can also attend at 6 p.m. But they also can look at half an hour to 45 minutes. Just look at what kind of paper that has the seen by the first session, so that second session people might get little bit help, the concepts or topics or the questions which are going to help you a lot. Yeah, and what we are going to discuss in this analysis, the difficulty level, mostly the paper 1, paper 2 will be similar, and subject wise weightage and answer key if possible. If you get the good questions and correct questions, then definitely, and the cutoff, a possible cutoff and safe score, everything will be discussed. All right, let's move on. So we are going to start. We have already started the post-GATE guidance for the those people who are written the GATE exam or who are writing the GATE exam, and that is already started. You can watch free classes on GradeUp. Yeah, good evening, Ram Sai, good evening. Yeah, Rahul, good evening. Sumitra, good evening. Yeah, Chandana, good evening. Anu, Good evening, Sakshi. Good evening. All right. So this is the Vision 2022 batch, and those people who are preparing for GATE 2022, and please join this Vision 2022 batch. What are the advantages you have? You have more than 600 plus live classes and more than 5,000 practice questions, 100 plus mock tests, and 100 plus study material chapter wise, whatever you need, and all things are on a single platform. Not just it is for the GATE, and we are going to launch a separate batches for even other upcoming exams other than the GATE 2. So you have plenty of benefits if you join GradeUp. So let's begin without wasting time. Now please like this session if you have not liked it, and also please share this link with your friends and our groups so that many people will join. So let them prepare, because you are working very hard from the beginning, and this is a time where you require revision. So I am trying to help you to make a revision, guys. Yes. All right. Yeah, Nikhil, good evening. Are you ready now? Can we start our revision? Yes, people are just now started coming to this channel. Yes, make this channel very popular, and we have so many things to discuss in the future. And yeah, sister, I'm on GradeUp. Just this is the second class on GradeUp. Yeah, Venkatesh, I will try if it is any possible to get the PDF. I will try. Yes, today might be possible because I'm teaching on PDF rather than PPT now. Yeah, duration of the class is 3 hours, guys. Let me start. Okay, in compiler design, I'm going to help you the revision on the phases of a compiler and lexical analysis and syntax analysis, syntax directed translation and intermediate code, as well as code optimization. Okay, so these are the important topics, which is, a compiler has very few topics compared to any other subject, like even digital logic, compiler design has similar weightage in the exam. Okay, please join the Telegram if you want to know about. So let me tell you, in the phases of compiler, what questions we can predict in the exam. The one thing is the match the following groups. Everybody knows the following groups. Suppose I make 2 groups. Let's say group 1. I'm sorry, guys. Okay. And group 2, there are 2 possible questions. Of course, I can make so many possible questions here. So I'm just making the group 1 might be input of the phase, and group 2 can be the phase of a compiler. Maybe group 1 is output of the phase, and group 2 can be phase of a compiler. And other possible matching, that is functionality of the phase, and other one is the phase. I can also ask other kind of question, that is group 1, the functionality. Some of the functionalities I can write in this group, and other group is phase. So these 3 possible questions are from the phase of compiler. So input, suppose if I say one example, let me give you one example, guys, so that you will have an idea what I'm trying to talk about. Suppose I want, let's say, lexical analysis in group 2. And what could be an input to that lexical phase? So you should be very careful, because input will be there, output will be there, and also functionality. Yes or no? There are 3 things for the same lexical phase. I can write here, same lexical phase, I have 3 things to think about. But depends on the question, the match is going to change. Depends on the question, the match is going to change. In the first one, the lexical phase, the input is the characters. You can say sequence of characters or character stream. Yes or no? This is one of the previous year GATE questions, so I can predict again if any question comes from this phases of a compiler. This is the most highly predicted question, guys. So look at that. In all these group 2s, you have the lexical phase, but in the group 1 only, the match is going to change. In this, the input is character stream. Is that correct? This is the matching, because the input of the lexical phase is the character stream, and lexical phase output what is the output of lexical phase? Quickly, what should be the statement that matches in the group 1? Now it is a token stream. You can't say character stream. Now it is a token stream. It's a very, very simple question, but if you do not apply, simple logic that are you looking for input or output of functionality, then there could be a problem. And here, the functionality, there are so many functionalities, guys. They may ask recognizing the tokens, or recognizing the tokens, or deleting the comments, or deleting the spaces, or finding the lexical error. All of them are the functionalities. Here, so many options are there. Here, recognizing the token recognition, or token generators, whatever it is, or comment recognizing or ignoring comments. So many functionalities here. I'm not writing all of them. So depends on the intention, the group 1 statement is going to change. Everybody clear? This is a one predictable question. This is a one predictable question from the phases of compiler. But when you go to the interview, why this many phases of the compiler? Why? But right now, don't worry about interviews. So this is a one predictable question, guys. Similarly, you can write syntax phase. What is the input? That is the token stream or sequence of tokens. Similarly, every phase will have an input. You can match out. Everybody clear? So let me give you one idea about it. Okay. Good. Green screen. Let me write with white color. Okay, we have the phases. Tell me about what you know about lexical analysis. And what do you know about just in the phases of compiler? Don't go beyond that. What we can predict in the exam about these 6 phases or 7 phases: intermediate code generation, and about code optimization. Yeah. Tell me what is the input to the lexical analysis and what is the input to all of them, and what is the output? Okay, here I'm just writing separately. Okay, fine. Now let's come to the answers one by one very quickly. Okay, input is just you told the character sequence. I'm just writing characters. Here output is tokens. But in between the functionality is there. I'm not talking about because we have the revision on the first chapter. So we are going to do that. And that uses finite data. I'm going to talk about everything about lexical analysis. Don't worry about it. These are only phases of compiler. In syntax analysis, same tokens, sequence or token stream or sequence of tokens, whatever it is. And syntax analysis produces parse tree. That is a derivation tree. And the parse tree is an input to semantic analysis. And that produces, come on guys, what it produces? You may call it as, yes, syntax is fine. Annotated parse tree. You can also call semantic tree, something like that. And ICG takes that annotated parse tree, APT, let's say, and it produces intermediate representation, let's say intermediate code. And the input is, I'm not taking code optimization. Actually, code optimization is there. I'm not writing there, but I'm just writing intermediate code, and it produces assembly code, target code, assembly or target. So I'm not talking about the code optimization because there are 2 types of code optimizations that can come after ICG, that can come after code generation. So that depends on your code optimization. You can think about it. There are 2 types of code optimizations. One is the intermediate code optimization, other one is target code optimization. So depends on that, the code optimization is going to change. All right. Clear? So this is expected from the phases of compiler. Is it difficult? It's so easy, right? and such questions you should never leave in the exam. That is going to be the rank booster, right everybody? Yeah, those people, even you are not aware of compiler design implementation, you can just understand the the phases. Okay, let's move on. Now we'll talk about the first phase of the compiler. So what is the first phase? Lexical analysis. Before this, let me help you one thing, that is symbol table. How many of you know about symbol table? Theoretical question may come from this. Come on, guys. What is a symbol table? Tell me everything you know about symbol table. What is a symbol table? Once you understand the symbol table, and all the points related to the symbol table should be answered immediately, if you have understood already. Okay, let me look at it. What is symbol table? And what is the purpose of symbol table? Who is going to use a symbol table? What is there in the symbol table? Right. I want all the answers, guys. I want all the answers. Symbol table is a symbol table? Right. Symbol table is a data structure. Good point, Agarwal. Good point. It is a data structure. Because it's a table. So it is definitely data structure. Good answer. But why do you need a data structure? Already you have a program in compiler. Because when you are scanning the program, there are so many things that compiler not aware of them. Of course, it has the rules, but you are writing your own symbols. They are basically called as identifiers. Because identifiers, we have given the name in the program. The compiler doesn't know what name you are going to give. It is going to scan, right? So this data structure helps to store attribute information. It's about the properties of all the lexemes. Attribute information of identifiers. What is attribute of identifier, guys? What is attribute? Maybe it is what kind of token, or what type of identifier, or which line it is occurred. Are you clear? And what is the address it represents? So many things are there for to represent identifier. So this attribute information is not easy for many people to understand, just like a database. If you have the table, you will have rows and columns. Columns represent attributes. Similarly, so you have attribute information of identifiers. Okay, let me talk about who is going to use this symbol table. Come on, guys. This was a previous GATE question. Who is going to use the symbol table? Only lexical analysis, only syntax, only semantic. Every phase of the compiler is going to use the symbol table, and it is one of the important questions for the exam. Every phase of a compiler need or access or can access symbol table. Either it can modify or it can use the information of the symbol table, guys, because it needs a lot of the information to compile the program. Yes, so this is one of the important point. And apart from this, is there any use of the symbol table? Apart from this, no. We just need the information of each attribute, each attribute of the identifier. So now let's talk about the lexical analysis. The first phase of the compiler is called as lexical analysis. Tell me, what are all the names that you have? Yes, error handler, that I am not talking about. Error handler, that I will talk about after some time. Okay, let's talk about lexical analysis. Why do you need lexical analysis, guys? Just that is what the revision is. Why do you need lexical analysis? To recognize the tokens, and also it produces the tokens. So to understand the tokens of the program. Second one is to understand the lexical errors of the program, so that either it can handle or it can produce an error. So let's talk about lexical analysis. Okay, so what do you know about lexical analysis? It scans entire program without leaving any character by character. This is the first point. And this is going to take much time because all the phases of the compiler is going to follow lexical analysis, and it is going to identify so many things. It identifies tokens and comments, spaces. All of them are identified by the lexical analysis, but it produces only one thing. What are they? Tokens, where the characters are grouped into token. Everybody knows that. It produces the tokens but ignores the comments and white spaces. And there is one more job. It detects lexical error, if any. And also it creates an entry, or it makes an entry into symbol table. Which kind of entries? Whenever it detects a token, whenever it detects this token, if that token is identifier, it's gonna make an entry into the symbol table. Everybody agree? Yes. So these are the points that you require for the exam. So anybody want to study about lexical analysis? And there is one more. Who is gonna help? The finite automata or regular expression or regular grammar can be used. Regular grammar can be used to design this lexical analysis. So these are the points you require. I think this is enough to understand, but when you study any textbook, it requires the more effort because you have the tools to understand this lexical analysis, but we don't need the practical things. Yes. Yeah, Katie, good evening. How are you? Yeah. Okay. Any doubt in this? Yes, no memory needed to look for the tokens. Exactly. Yeah. So any question comes in the gate, the most of the times that must be from here. Okay, let's move to, without wasting the time, syntax analysis. And also you need to practice how to identify the tokens. If you have remembered, there's one thing we are losing. It produces the tokens, but how? How it produces the tokens? Anybody, guys? How it produces tokens? By using which rule? By using the longest prefix rule. And there you may be asked one practical question. Longest prefix rule. They will give you the rules T1, T2, T3, and they will ask what is the sequence of tokens for the given input. Do you want to practice that? This is one of the previous year gate question by using the longest prefix rule, also called as maximal munch rule. Yes or no? Also called as maximal munch rule. Right? Have you remembered that? Dhruv, it's not longest sequence, it is the longest prefix. Longest prefix rule. Yes. Correct, correct. Look at one example to practice. Okay, these are my 3 tokens. This I have created my own rule. Yes, this is the one question I am taking. And it's a very interesting question how the lexical analyzer works. Yes. Now this is my input. My input is okay, that's all. This is my input, and you need to identify what is the sequence of tokens produced. Here there are no spaces, guys. It's not just a C, it's not a C program. It's my own program that I have created here, and somebody implemented the rules in lexical analysis. Yeah, tell me what is the sequence of tokens are produced. Yes, very interesting question, guys. And you may not be seen this question ever. Even I don't know. I just created this based on my knowledge. Come on, come on. I want the answer from you. Let's see who will answer this question. You have 2 minutes of time. Come on, guys. T2, T1. Is that correct? Check it, guys. Is it right? T2, T1. That's all. T2, T1 is right answer. It's right answer. T2, T1 is right answer. But how did you do that? So many people are wondering, how did you get T2, T1? Because you might be not good at regular expressions. These are the regular expressions only. Yes, T2, T1. Have you remembered my technique? Have you remembered my technique to identify that? Oh, it's not T2, T2, Shashwat. Sorry. Yeah. Little bit practice required, right, Shashwat? Yeah. Silly mistake can cost your GATE exam. Okay, T2. How do you do that? And now everybody participates in the race. T1, T2, T3, all participating. Now look at T1 and T2, T3. Everybody participating in the race. Let's see who will succeed by matching the longest prefix. T2, T2. Yeah, I will come to Shashwat. Don't argue. Ask for help. I will help you. T1. Let's see why T2, T2. Who is that? T2, T2. Why fails? Look at it. T1 can generate A but not complete. And T2 can generate A. Yes. T3 also can generate A. And when you go to B, AB. Yes, T1 can generate. And T2 can also generate AB. But T3 cannot generate AB because only A is there. It's not whole star. So here T3 fails in the race. Everybody agree? Now T1, T2 only. Now when it comes here, after AB, can you generate another B? No, it fails here. But T2 still it can continue. Yes, AB, B, alright. And still it's C. And this is only matched by T2. Everybody agree? Now everybody starts the race here onwards. Everybody starts in a race, that is here onwards we are going to begin. Here onwards. So let me begin again. Now T1 can generate A and T2 can generate A. T3 can also generate A. But after that, look at T1 can participate in AB. But T2 can also participate in AB. And T3, AB is not possible. But that's all, my input is over. But here T2 is not generating AB, it is generating ABC. T2 cannot generate just AB, it needs a C. If you have a C after that, you are right. Who is that? Who was talking about? Then only T2 was our answer. T2 is right only when you have the C, because T2 always ends with the C. But we don't have that. So that is what I am talking about. Who was doing the mistake? Okay, all right. Okay, now who is going to win? That only the T1 only can generate AB and T3 cannot generate AB. T2 requires a C here. Remember that. Clear this point? Whoever was doing the mistake, this was your mistake. C required if you want to write T2. But that is the reason T1 is the right answer. This is the output produced by the lexical analyzer after recognizing the input by using the rules that is implemented by somebody else. Yes. In place of B, it is a C. Yes, A, C. Yes, good point. Who is that? Nishu Kumar. Yes. If you don't have a B, if you have the C, then only T2 can win the race. But T2 fails to win the race because just it needs a C more. Alright. So got the point? This is about lexical analysis. Are you ready to move to the syntax analysis, which is the very important one for the compiler design? You know that syntax analysis is a very important topic. Are you ready? Come on, guys. I need a response. I moved to this platform to show, how do I teach basically, but that's not the important one. How do you learn is important. Yes. Are you clear? Come on. Is that clear? So, did you get the revision in lexical analysis? Right? Now, after this, just revise the 2 slides. It's enough. Now, come to the point. Syntax analysis. If you want to revise the syntax analysis, focus on what are the ambiguous and unambiguous grammar, and how to compute the first and follow set, and how to identify LL1 grammar, and how to identify LR grammars. There are so many, you know that, and how to compare all the grammars, and parses grammars and languages. Surendra, I'm sorry right now, but I can help you on GradeUp platform. You can ask that question on GradeUp. I will help you. I will help you. Those people who are asking out of the syllabus, the GradeUp has a very good interesting fact, that is, you can ask any doubt on the GradeUp. Somebody will come for you to clarify. Please install the GradeUp app and ask any doubt that you have in the semester or in the GATE exam or in any other exam. Somebody will help you. If you can tag the people, you can tag the people like WhatsApp, Facebook, whatever. Yeah, we have the last topic is operator precedence relations. Come on. Okay, let's move to the first one. Tell me what are the things you have learned in ambiguous and unambiguous. Have you remembered all the concepts? Let me revise these 2 points. What is ambiguous? Okay. There are 2 kinds of grammars. Ambiguous grammar. Suppose anybody saying G is ambiguous CFG. If and only if there is some string, which belongs to the language generated by the given grammar. That means that grammar generates the string which has more than one parse tree. Very simple definition. It could be asked theoretically or with example, whatever it is. And what is unambiguous? In case if G is unambiguous CFG, if and only if for all W that are generated by the language of the grammar, that are generated by the given grammar, as exactly one parse tree. Very simple. One parse tree means one LMD, one LMD means one RMD. Okay, it is just definition. Let's look at the examples. Because I want to make a revision, but before making the revision, I will just revise the concept, because to get an idea if anybody is new to this session, right? Don't assume this is I'm going to teach. I'm going to teach examples that you need a revision. So let's practice examples. Okay, tell me what are all the techniques that you can apply in the exam that is possible to answer quickly. Okay, first point, you take any string. Every string, there is one point is important. What is it? Number of parse trees that derives the given string, which is equal to number of leftmost derivations equal to number of rightmost derivations. Do you agree? Whether it is one or more than one doesn't matter, but all these 3 always matches. If I have 10 parse trees, definitely will have 10 LMDs. Yes or no? Yeah, good evening Priyabrata. Welcome to the YouTube channel, guys. Please like this session and also share with your friends, and we need to reach 200 at any cost today, guys. Right? Yesterday I was not able to look at the users, but today I'm able to look at. We are at 150 now. We should cross 200, guys. Yes. Come on, quick. That is the first point. If any question comes on these 3 relations, say that. Second point, for any given string, LMD and RMD need not be same. It can be different. Why need not be same? Because the substitution of non-terminals are different in both of them. If LMD substitutes leftmost non-terminal, RMD substitutes rightmost non-terminal. Yes or no? Yes, sometimes LMD, RMD can be same, but not all the time. Yes, come on guys. We have reached 164 live users. Now, come on. Is it clear? This was the previous year GATE question. In future, I predict this one. In future. So please note down that it is possible to be asked in the coming exam. Third point, how do you identify the ambiguous and unambiguous? We have the shortcuts for them. So I'm just giving, if you have, look at this. By looking at this grammar, can you say it is ambiguous? Have you remembered the shortcut to identify? Of course, this doesn't work all the time, but sometimes only to save our time in the exam, to eliminate the options or to choose the options very quickly. And what is this? Quick, what is this? Is it ambiguous or unambiguous without using pen and paper? Without using pen and paper, guys. Is it ambiguous or unambiguous? जिसको मालूम नहीं है बता देना जल्दी क्या है? Yes, hello नीरज. Ambiguous. ये LL1 पूछ रहा है. जय कुमार, मैं LL1 नहीं बता रहा हूँ यार. I want ambiguous or unambiguous. जल्दी. Don't waste my time. It is ambiguous. What is the shortcut that you made to identify it? Because I have, this is going to participate in left recursion and this is going to participate in right recursion, and this is useful non-terminal. We never talk about useless non-terminal. Remember, S is useful non-terminal because it does some job. And now you can see this creates ambiguous because of left-right recursion. You can ask me, sir, which string? Can you identify that? Obviously, you can identify. Yes. So what is the note you have to make here? Note. If, not only yes, it can be any non-terminal, guys. If any non-terminal in the grammar has both left and right recursion, then directly you say it. Then grammar is ambiguous. Yeah, that's a very easy point, and you can save a lot of time in compiler. You can save a lot of time in compiler if you have such tricks. Because basically, if you are studying on your own, this kind of tricks you may not remember. You may not have the knowledge. So I'm just telling about. So please use this knowledge to save your time. Let's move. Fourth one. Look at this one. And it is very difficult to identify ambiguous in some cases. This is one of the best example where there is no left recursion and right recursion. Can you see the right recursion you have for A, right recursion you have for B, but there is no left recursion for A, there is no left recursion for B. S has no recursion at all. So directly you cannot answer now. You need to have the knowledge. Now you need to have the knowledge of the definition. Tell me, is it ambiguous now? Because now the string AB has more than one parse tree. It means ambiguous. Yes or no? Quick, yes or no? Yes. Yes. When you don't have left and right recursion, we don't know what is going to happen. But when you have, suppose if I add one thing here, it's going to be ambiguous no matter what is the grammar it is. If I add that, it's going to be ambiguous without looking at this example. You don't need an example to answer. If I have this production here I have a right recursion, I have left recursion, both together makes ambiguous in the language. Everybody? So you can easily answer it if you have both left and right. But if you have only right, you can't answer it. Okay? And for the same non-terminal, you should look at it, not at different non-terminals. Okay. Now let's look at some examples. Quickly answer it. One of the favorite topic in GATE exam, ambiguous grammars. Look at, I can see more than 10 examples which talks about ambiguous. So I recommend you to practice ambiguous. Grammars. Yes. Okay. Now tell me very quickly, what is the answer? Chalo. Answer it very quickly. Look at how much time you can save in the exam if such questions comes. Yes, definition and this trick is different. Yes. GATE student, I am not asking about not LL1. I am asking about ambiguous. LL1 will create another shortcut for us. Are all of them are ambiguous? Look at how do I apply our principle. Here you have a left recursion and also right recursion. So definitely it is ambiguous. But also look at, if you don't have this A, you're not eligible to say ambiguous, guys. You're not eligible to say ambiguous. If you have this thing, you're not eligible because the useless grammar. Nobody should ask in the world, is it ambiguous or unambiguous? Nobody should ask this one because it can't generate any string, right? It can't generate any string. So this is useless grammar at all. This is a useless grammar. Okay, you must have here something to produce. We always talk about useful grammar. All right, this is also ambiguous. Quick. Left, right, and here right, here left. But do not say something which is looks like left right recursion. Look at this example. Everybody clear? Without checking any string, I was able to say they are ambiguous grammars. Yes or no? Yes. New platform. Parik. Yes. Clear? Yes, Vivek, I left. Okay, let's go to the, which example? 8. Okay, let's see who will answer this one. Okay, is it ambiguous or not? Come on. Is it ambiguous or not? Now you check yourself. Directly you cannot say ambiguous. You have to check manually. Don't say unambiguous directly. You have to look at now, is there any string that can generate or that can be generated by more than one parse string? Is there any string which has more than one LMD? Come on, quick. अमन, आपके सामने IIT बॉम्बे ऑप्शन आया और IIT Madras option आया. Which one you will choose? Depends on your knowledge, right? Even for me, when you have more than one option, I will always choose whichever I feel comfortable. All right. Right. Is it ambiguous or unambiguous? Quick. Unambiguous. But don't look at A has the right recursion, S has the left recursion. Don't answer ambiguous. Be careful. We will talk about the same non-terminal. So when I look at the strings, okay, whenever that ends with A, S is repeating something, but whenever I start with B, something like which has some other concept, looks like there is no string which has more than one parse string. So this is very difficult grammar. I'm writing it. I'm also not a good person to answer this answer, right? I'm not also having knowledge of this grammar. The reason is unambiguous. When the grammar is unambiguous, the people waste their time to answer it. The people waste their time because there is no way to prove it. There is no way to prove it, guys. Because how can I show every string has one parse string? Is it possible? Because infinite strings are there here. Only you can understand by definition. Understand by definition, every string I tried, but I didn't try. Only that is analysis, that is only assumption. Every string, by understanding, every string has one PT, one parse string. That is how the unambiguous grammars are really difficult to answer why they are unambiguous. Okay, come on, don't worry about much. It's not just this grammar. Most of the unambiguous grammars are difficult in the world. Okay, is it clear about ambiguous and unambiguous? If the grammar is ambiguous, sometimes you have a shortcut, apply it. Yes, Bharatendra, you are right. It is undecidable problem. Guys, remember, if you are combining TOC compiler, in compiler we use ambiguous and unambiguous. Verifying the ambiguous, verifying the unambiguous grammars are really undecidable problems. Yes. Now let's come to the second topic. First and follow set. First and follow set. First and follow set. Have you remembered all the definitions? Come on, quick. I will just give a few things. You can remember that 3 points whenever you compute first and follow. Just 3 points. Okay, first point. If you see terminal, answer is very easy. But where do you see the terminal? I will talk about that. If you see terminal, very easy. Second, if you see non-terminal someplace, wherever you want it, then you have two things. Can it derive? If it not derives epsilon, again easy. Again easy. But if it derives epsilon, it wastes your time. If it derives epsilon, it's one takes time. Takes time to compute. It's not always difficult, but takes time. Remember these 3 points while computing first and follow. Are you clear this point? While you compute first and follow, focus on 3 things. Are you able to see the terminal? Answer is over. If you are seeing non-terminal, look at, if you don't derive epsilon from that non-terminal, answer is gonna be easy, no matter what the grammar is. Yes. And if it derives epsilon, then it takes time. It takes time. So both of them, you have the same problem. And here, if you look at the third point, if you look at this point, it takes time. Are you clear? Are you ready to look at the definitions? Look at. Suppose the first example. Okay, look at. Are you able to see the terminal? In seconds, in 2 or 3 seconds, you can calculate. If I ask what is the first of S, answer is over. Just answer is over. Just look at the grammar and answer it. What is the answer? How did you get that? How did you get that, guys? A comma G. Did I say that? There are 3 points you need to remember. If you see the terminal, whatever the first terminal derived from S, that is going to appear in the first of S. Clear this point? This is what I am talking about. If you see the terminal, answer is easy in the exam. So you don't have much time to calculate. You don't need much time to calculate. That's true. Okay, now let's go to the second question. The people face difficulty. I'm making you revision to remember that. In case if you see yes here, let me write something. Now look at, who is there here? Yes, of course the G is there, so answer is there. First of S is equal to, no doubt it is G. But here, is that S derives epsilon or not? That is going to decide your answer. Tell me now, is that S derives epsilon? No. Are you clear? Okay, I will compute the follow later on. Who is that? Chetan. I will compute later on. Right. S. If I am trying to substitute, again GHE should come. Again you get a G only. So that is all you have answer here. If that is a non-terminal capital A, go to capital A and compute and come back. Everybody, this non-terminal is not deriving epsilon, so it's also easy. Again G only comes here, so G comma G no need to write. Actually G union you should write first of S, but first of S is again gets a G, so no need to calculate here. Yes, this is the second point I am talking about. Now the third point. Where we face so many times it is difficult because of the concept. Now look at, now is that S can derive epsilon, and this is how you need to practice and careful when you answer such questions. If I ask here first of S, this question should be careful when you calculate in the exam. Hari bari epsilon answer kiya nahi chalega, right? Why A is not coming? Because S always gives something that is G. Always gives G as the first. ये पर कब जाओगे यार? ये पर नहीं जाओगे. Follow of S ये आएगा, first of S नहीं पढ़े क्या definition? Okay, what is the first of S? अब आएगा. First you can write epsilon, and epsilon when you put A also comes here. Look at that. Why did I say that? When S derives epsilon, put epsilon there, you get A, because epsilon nobody can see that. But here when you put G only comes as the first, so we deleted first of S. We don't compute again. Clear everyone? No. Who is that? Parekh, it is not. It is a valid grammar, but it generates empty. Parth, it is a valid grammar, but that generates empty language. It cannot generate any string. Yeah, you are right. That is a valid grammar, but it can't generate valid string. That is a problem. Okay, please look at that question. The Parekh is asking one question which looks like very interesting. Yeah. Right? Clear everyone? These three examples should focus when you are computing first set. Let's go to the follow set. Okay, in the follow set also we'll see three interesting questions. Now, I want to compute the follow of S. What do you get? What do you get follow of S? Is there any S in the RHS? Is there any S in the RHS? Yeah. Is there any S in the RHS? When there is no S, you will not get any follower except the dollar, because this we assume as the special symbol end of input or end of token stream. So this is what we assume all the time, and dollar is always the follower of the start symbol. Everybody? Yes. That is the first point. And second point, if you have suppose SA or B, now look at how to compute the follow of S. How to compute the follow of S? Quick. Now what are the followers that you can compute for the follow of S? Yes. And in this point, in this grammar, there are some students, they may forget about the dollar. So first always practice by keeping the dollar in the follow set. Follow of S is equal to, always practice keeping the dollar if S is a start symbol. If S is a start symbol, always keep practicing the dollar, because there is a chance of forgetting it. And yeah, other one you can look at now. Why this grammar is so easy? Because after this S, who is there? We are not computing first of S. If you compute first of S, B comes. But if you compute follow of S, A comes. A is there as the follower. Everybody? So now terminal is there just after S. So answer is straightforward. This is a terminal example. This is a terminal example. Now we are going for non-terminal example. Right? Yeah. Okay, let's move to the third example. Okay, now look at, we have two non-terminals. How do we compute? Because you know 50% of the probability you may be getting the question from first and follow. So I'm just making you revision. How do you compute them very quickly? Okay. Now we have two computations. Follow of S, follow of A. Okay. I'm sorry guys. I cannot create two examples now. So I'm just modifying the grammar. Just add here C. Okay. To make it easy, I will take another example to explain that. Follow of A. Now tell me what is the follow of A, which is very easy now, because after A you have a C, directly you can answer C. But follow of S is the difficult. Follow of S is slightly difficult. Now why is difficult? Because we write a dollar. Now after S, who is there? A is there, but is a capital A is not a terminal. Yes or no? Capital A is not a terminal. What is that? Is a capital A is a non-terminal. So when it is non-terminal, you need to know about what capital A derives. Tell me what capital A derives. Somebody has to compute what is the first of A. Then only you will know what is the terminal that is followed by the capital S. So what is the first of A, which is B? What is the first of A, which is B? And now follow of S, when you ask here B, D comes, among them the B is the first symbol that is going to appear after S. So we are going to write union first of A. That makes dollar comma B. Yeah, that's good. Dollar comma B is the right answer. Okay, now let's come to the point. This third is the second scenario where non-terminal appears, but non-terminal will not derive epsilon. So that's why it looks so easy. Now we'll go to the third example, or third type or third model, where capital A, if suppose derives epsilon, how difficult it is. Okay, now let's focus on both the things. What is the follow of S and what is the follow of A? Come on, quick. This is what we predict in the exam. If you can answer this thing, then almost first time follow you are good at. The LL1 grammar, LR1 grammar easily can be computed. Yes guys, come on, quick. And I hope you remember, tomorrow we have 50 questions from all the subjects. I am predicting the 50 plus marks from that tomorrow 6-hour session, but each one I am going to discuss in detail. Whoever practice that, at least if it is not 50, it is nearby 50, is going to be helpful for tomorrow session. I'm going to conduct who are preparing from the last 2 to 3 months and you want to secure good marks, please attend tomorrow's session, which is gonna help you 50 questions from all the subjects including Aptitude, mathematics, but I've only selected the questions which I'm predicting. Fine. So tell me the answers quickly. What is the follow of A? Oh, A is only one place it is appeared, so after A, C has to come, so we answer C. Over. But when it comes to S, S is a start symbol, so definitely you should write a dollar. And now, after S, if you are looking at, A is coming. And capital A, is it always giving a terminal? No, it has two choices. It can get a B. Yes, we write a B. But when you write epsilon, that follow of S, we never say epsilon, because follow of S, if you put epsilon C is nothing but, now together will create a C as the next symbol. Yes, this is where the people filters the computation of the follow set. If you are good at computation or not, just check this example. If you are able to understand this grammar, that is, you are good at follow set computation. Just take this example and work out why did I get B comma C? Because capital A derives epsilon. If I ask who is after S, either B can come or C can come. C can also possible if here epsilon comes. Right? Because capital A, you can put epsilon there. Alright, that's a good one. BC comma dollar. So what are the questions are predictable in the exam? They may ask what is the size of the follow of S? You should say 3. And is that B belongs to follow of S? Yes, that is true. If they say D belongs to follow of S, no, that's false. So such questions we can predict in the exam. You can easily calculate now. Now there is a fourth point. There is fifth question and fourth point. And remember these 5 examples. S derives A and A derives B. And tell me if I ask what is the follow of, yes, that is dollar. That's true. And but what is the follow of A? Whenever I ask follow of A, S is not there, so follow of S is dollar, but A is there in the RHS side. Who is after A? No one. There is nobody. But there is somebody in the derivation. Here nobody in the grammar, but there is somebody in the derivation. Whoever is there after S, same one will follow. So we say that simply follow of S. Whatever follow of S, we just copy paste. Everyone, that's going to be easy. So I have given you 3 points in the first set and I have given you 5 points in the follow set. Please keep in your notes so that this is going to help you for solving any problem you require. Yes or no? अगर ये आपके पास 5 पॉइंट है, कैन यू आंसर एनी क्वेश्चन टू कंप्यूट द फॉलो सेट? Is this possible to compute any non-terminal follow set? If you have these 5 points, look at the 5 points quickly. First point, is this first set? Okay, wait. First point, S is not there in the RHS side, dollar included. Second point, S is there and terminal immediately comes, copy paste. S is a start symbol, so dollar, and A is there, just copy paste. And third point, after S non-terminal is there, but non-terminal always gives a small b, so we copied. Where is that? Here. After S, follow of S, dollar union first of A. Here, B we copied it because B directly comes here. Yeah, this is the third example. And fourth example is, and after S non-terminal is there, sometimes terminals comes there, sometimes epsilon comes there. When epsilon comes, the S follower C will appear there. So here C is very important. Okay, and the fifth example, if nobody is there after A, you are computing follow of A and you copy it, follow of A, nothing but follow of S. So these are the 5 rules are going to help you for the exam point of view. Yeah, tomorrow session timing will be 9 a.m. Morning 9 a.m. guys. Because day after tomorrow I cannot take that session because you require one day enough time to balance your mind. That is the reason tomorrow I am conducting that session. Yes. Okay, now are you ready for relevant grammar? Are you ready for relevant grammar? Come on guys. Are you ready for relevant grammar? Okay. बहुत अच्छा डिस्कशन चल रहा है यार यूट्यूब में. उमेश पाठक, yes. Tomorrow at 9 a.m. निशु, आर सब्जेक्ट पढ़ाएंगे कल का सेक्शन बहुत इंपॉर्टेंट है because every subject is going to come into one session, every subject. So I feel that tomorrow session is going to help you for every student. And 12 subject, 12 subjects, every subject 3-4 concepts are going to come, 3 or 4 or 5, depends on the importance. And I'm going to conduct tomorrow 12 subjects, 50 questions. That 50 questions I am predicting in the exam, if that 50 questions are going to help you for 50 marks and you are going to remember for me long time, and if not, at least you should get a minimum average 30 to 40 questions guys. So tomorrow's session is going to be important for everyone and 50 questions from all these subjects. All right. Yeah, Chetan. All right, Nishu. Tomorrow 9 a.m. we will have the 50 questions. Already you can get the link which is already available in future live streams, upcoming live streams. Yes, on the same channel. If you have not subscribed this channel, please subscribe this channel. And also, please, if you are preparing for GATE 2022, I recommend to download the GradeUp app and follow us, ask doubts. Remember that, ask doubts and learn from us. Yes. Paper out, Jay Kumar. Nahi yaar, paper out nahi yaar. All right. Chalo. Are you ready for relevant grammar? What is relevant grammar? It is CFG. Be careful. It is. We are not saying it equivalent. Remember that. It is CFG. Only with this direction. CFG no need to be. That direction please don't write. And it is. What else you know about? Relevant grammar? Quickly guys. 9 a.m. Vivek, not 9 p.m. ये तो टाइम ही चेंज कर रहा है यार. कल की टाइमिंग 9 a.m. in the morning guys. Please don't change the timing यार. And it is unambiguous. और क्या जल्दी. Any relevant grammar also should not have left recursion. So it is a non-left recursive. And it should be left factored. So these are the 4 points you should remember about relevant grammar. And don't apply other direction no need to be true. CFG no need to be LL1 grammar. Unambiguous no need to be LL1. And non-left recursive no need to be LL1. Left factor no need to be LL1. But if it is LL1, it's gonna satisfy all 4. Look at the example that I'm going to talk about. Look at one example guys. I have one favorite example with me. Look at this example. Tell me, look at this example. Is it context-free grammar? Look at this example. Please try to remember this example, which will help you so many confusions, which will help you to clear so many confusions. Is it context-free grammar? Yes. Is it unambiguous? Yes. Is it having left recursion? No. Is it left factored? Yes. But it is not LL1 grammar. It is not LL1 grammar. The reason is, anybody? From S, if you look at the A column in the table, you will have both the productions. But this is not LL1. This is not LL1. Even though I satisfied all the 4, it is not LL1. Are you clear? Why I am talking about one direction only you have to think, because other direction need not be true. Even I am satisfying all the 4, no guarantee the grammar is LL1. Are you clear? This is the best example. There is no explanation directly in theoretically. Right? Practically we have example. We have a shortcut to understand. We will calculate. You can calculate. Who is the first of this one? First of ASA is what? Is A. And because of epsilon, in the derivation, you require to compute follow of S. What is the follow of S? You get A. So here you will get A. So there is a common terminal from both the productions that you are not able to see directly. But during the derivation only you will see them. From S, if I want to derive A, I can choose this production or this production. From both the production, I can get A as the next symbol, next token. That is the reason this is one of the difficult example for undergraduate students. As a faculty, this example I learned very slowly, guys. That is the reason I am talking about. Is that clear? You have a shortcut to understand why it is not L1, but it is satisfying all of them. It is satisfying CFG, unambiguous, non-left recursive, even also left factored. Clear? Intersection, when you do, it's not equal to pi because there is a common terminal between them. Not equal to pi. That means, oh, who is that? Nishu, wrong. Equal to pi then LL1. Not equal to pi means there is a problem. And I will tell you the shortcut later on. But guys, remember, not equal to pi means not equal to empty. Means there is a common terminal. Means there is some problem. That means it is not LL1. So be careful. Don't use that word equal to pi, not equal to pi. You don't understand. Understand, not equal to pi means there is somebody common. If there is somebody common, there is a confusion between the choosing the productions. Clear this point? Yes, yes. And mark this example and look at have you learned this before or not. Even though I satisfied all the 4, there is no guarantee of LL1. Okay, just question yourself. Okay, now let me talk about LL1 grammars a little bit more. We have a shortcut. Which shortcut? See, yes, on A, you might have these 2 productions and epsilon. Yes or no? This is S derives epsilon. This is S derives ASA. This is one way you can detect the given grammar is not LL1. Yes or no? This is one way you detect. If you know how to construct the table, this is the one technique where you can say the given grammar is LL1, not LL1. Because you have multiple productions in the same combination, S comma A. And there is another shortcut that I told you. There are 2 rules to identify given grammar is LL1. Did you remember the 2 rules? Quick. ये rules याद रखना पड़ेगा exam के लिए. Exam के लिए 2 rules याद रखना पड़ेगा, guys, at any cost, because that can save your time. Table construction takes much time. Table construction takes much time. Here, what do you do? First rule, x alpha 1, alpha 2. Just to compute, assume these 2 are not epsilons. This is also not equal to epsilon. This is also. Then what do you do? First of alpha 1 intersection first of alpha 2. In case if you get not equal to pi, means it is not LL1. Given grammar is not LL1. Directly you can say. If you want to say LL1, this is not enough. If you want to say LL1, this is not enough. You have to apply for every non-terminal this rule. you have to apply entire grammar, these rules, 2 rules. And second rule, in case if you have epsilon, if this is your production and if it's compute, alpha is not equal to epsilon anyhow. If first of alpha intersection follow of x is not equal to pi, then also not LL1. So saying not LL1 is always easy in the compiler rather than saying LL1. Are you clear this point? Yes. Have you recalled these shortcuts? Are you going to use the table in the exam? Are you going to use these 2 shortcuts? And these 2 shortcuts can save your time in the compiler. Do you agree or not? Come on guys. Pura compiler ko 3 घंटे में पढ़ाना, it's not possible, but we are making it possible based on your feedback. Yes. Please try to interact each and every minute so that you can connect to this concept. अगर सामने वीडियो के सामने बैठ के यार मूवी जैसे देख रहे हैं, I don't like it guys. चलो इंटरेक्ट करते रहना guys. How do I know यार 160 people are there in the live? चार्ट भागना पड़ेगा यार, चार्ट नहीं भाग रहा है यार, बहुत बोर लग रहा है पढ़ाना मुझे. Come on, ये नहीं होता यार. I'm working hard for you, but I'm just expecting interaction. Yes, Guru, I will do that. He want left factoring, I will do that. But not left recursion elimination, it takes time. Yes, tomorrow C programming and day after tomorrow discrete mathematics. There are 2 more subjects are going to come for the revision. Yeah. Alright. Example also going to come. Okay, let's practice. Now, how do you apply these 2 rules to this example? And this example is enough to practice. Yeah, thank you, sister. That was the glass board, right? Nobody was interacting with me. I was teaching to myself there. All right. Now, how do you apply the rule? Look at that. This is gonna be rule 1. Rule 1 you apply. For this, you apply rule 1. And here you apply rule 2. And again you apply rule 2. But no need to apply to all of them. In case at any point you got not equal to empty, stop there and say not L1. That's all. Everybody? Is that clear? Come on. Is that clear? At any point you got not equal by, stop and say not L1. But everybody got equal to pi. And then only the result is LL1. Clear this point? Not LL1, just one reason. LL1, everybody is the reason. Clear everyone? Not LL1 always easy to answer rather than LL1. Now अब कर लो rule 1. ये क्या है? फटाफट. Yeah, A and C. Is it empty or not empty? यहाँ पे तो A आएगा. यहाँ पे तो C. A intersection C is equal to pi. So that's fine. There was no confusion with that combination. Yes or no? Alright. Next. This 2. When I apply this rule 1, is there any problem? A and D, no problem. Intersection is empty. A and D intersection is empty. But A दोनों का थोड़ा time लगेगा. It will take time because epsilon means you need to compute the fall of A. So for this 2, I'm going to do something. That is, one is you are going to get D intersection. This one is the fall of A. So go to the grammar and compute the fall of A and come back. Fall of A, nothing but fall of S. Fall of S, nothing but B comes and dollar comes and B comma dollar. And fall of A, nothing but fall of A, no need to compute. So this is going to come as a B comma dollar. Let me know if you get different answer. Fall of A, is it B comma dollar? Check it. Fall of A, nothing but here fall of S. Fall of S, nothing but dollar, and after S you have a B. So dollar comma B. Yes or no? Yes. Thank you so much. And 1 hour we have realized that. Yes. Thank you so much for recognizing Garima Singh. That is 1 hour is gone. Even I didn't realize that 1 hour is over at. Right. 1 hour is completed and we crossed it. Still I didn't feel it because Always interactive sessions are amazing, and if you are coming to interaction, even I can get more concepts in front of you that I have not thought so far. Only the interaction can make the class is very beautiful. Yes. Now any problem with this? No problem. This is also. And look at this too. Here you get a intersection, and from here you get a b comma dollar. Sorry, b comma dollar. Yes. It is also pi. All of them are giving equal to pi, means the given grammar is LL1. This is LL1. Clear? But आपको ये चेक नहीं करना कभी, ये ambiguous है नहीं, टाइम लगेगा. ये left recursion है, नहीं आएगा. Left factored है, नहीं समझ में आएगा. Are you clear? Only the shortcut can help you. Only the shortcut can help you now. Yes, yes. If it is not LL1, sometimes theory, knowledge can help you. Sometimes the shortcut can stop to say not L1. All right. Let's move. And somebody want left factoring before this. Left factoring. यार ये difficult है क्या left factoring? Okay, one example guys, not much. Left factoring is a concept, is algorithm. Give any grammar, it will try to make left factored grammar. Any CFG I am talking about. Left factored CFG. If it is already left factored, you will get the same output. If it is not, it will make left factored. So what is left factored? Suppose you have S derives A or AB. This is not left factored because you have a common prefix. Left factoring nothing but eliminating common prefixes. That is the algorithm. Eliminating common prefixes. But of which length? Prefix of one length or two length? Because we are looking at LL1 parser, so we look at only one length. So this one length we are looking at. And A is a common, so we are going to delete that. So A I keep once, X, and X can take care of the after A. After A, epsilon is there, or here B is there. Now you can see there is no common prefix of one length. In this grammar, we are looking for eliminating common prefixes of one length. Two length we don't do it because we are not implementing LL2 parser. Clear? In LL2 we look for two length. That's different. That's not there in the syllabus, but understand it. Yes, it is LL2. Good example. This grammar is LL2. Yeah, I will take that too. Is that clear? What is left factoring? It takes any context-free grammar, it eliminates common prefixes and converts into left factored grammar. Are you right? It's a left factored grammar now. Epsilon we don't look at because we look for one length. Here this is a zero length, that is one length. There is no problem in the one length. All right. Now there is a good example I have. A or AB or ABC or ABD. Tell me which grammar it is. I have one question for this. Is it LL0 CFG? Option A. Option B, it is LL1 CFG. Option C is LL2 CFG. Option D, LL3. Which is right answer? Let's do it. Yeah, of course all the rules are applicable, but now you need to look at the left factoring concept. It is unambiguous, no doubt. It's unambiguous. No left recursion, yes. It is a context-free grammar and common prefixes are there. Which one is the right answer? LL3. LL3. When you look at one length, there is a problem. Look at one length. Oh, so many problems are there. Here, one length. Okay, that means if I get the next token is A, I don't know which production to choose. But when I look at two length, okay, here AB, there are so many problems. Okay, when I look at two length also I'm getting a problem, so it is not LL2. And when I look at the three length, everybody is different. When I look at the three length, everybody is different, so this grammar is LL3. Clear? Yes, option D. Can we move to the next concept? LR grammars. I hope this LL concept is enough for the exam, but you should practice if you have already attempting the mock test, and you should know this kind of the things you are doing once in a while. Are you ready to move to the next one? Come on guys, are you ready? The next important one, LR grammars. Yeah, भागना नहीं, क्यों questions बहुत easy आता है exam में. Questions are so easy in the exam. Okay, LR grammars. Tell me, what do you know about LR grammars? How do you identify it? I will talk about the parsers later. Just theoretical point, तुषार. जो इससे पहले यार gate question देखो, what is a viable prefix? है ना, viable prefix comes on the top of the stack. That's all the previous year gate question. Viable prefix comes on the top of the stack, but it need not be one symbol, it can be sequence of symbols. Okay, that's what the previous year gate question. Theoretically is so important now, right? Okay, now LR grammars. How many types of grammars are there in LR? LR0, theoretical grammar. SLR1 grammar, LALR1 grammar. Other one is LR1, also called as CLR1 grammar, also called as. Okay, and you know what is the difference between LL1 and LR1? What is the difference between LL1 and LR1? Only one thing I am giving, remaining I will talk about later. LL1 and LR1. What is the difference? One is here, look at our prediction, you can call here prediction. Of course, here also prediction, we call here look ahead. We just change the names, but both meanings are same. That one represents look ahead, but we call as a predictor, and this called as look ahead. Both are going to represent who is the next token. Next one token we are going to represent there. Here both L's are there. This L and this L represent same. They scan from left to right. Whether it is bottom up or top down parser, doesn't matter. When you are using these grammars, that first L represent the left to right scan. This was a previous year gate question. What is this R represent? It is RMD in reverse. And this L represent LMD, that's all. It's not in reverse, remember that. This was a previous year gate question. All the bottom up parsers follows RMD in reverse. Right? This was the 2 years before the gate question, and you do not need much knowledge to answer it. Yes, Nishu, you are right. It can parse even ambiguous, but not all ambiguous, remember that. Clear? The difference between LL1 and LR1 abbreviations. Okay, come to the next point. Here, 0 means we don't have the look ahead knowledge. We don't have the prediction. Here, 0 means we don't have a knowledge. It's a very easy to implement. Very easy. And S represents simple. And this LA represent a look ahead. And this C represent canonical. Canonical means exact. And I'm going to talk about the differences once you talk about all of them. So let me explain you one example. Then we will combine all of them. Clear? Are you ready for that? Simple LR1. Simple LR. Everybody? Simple LR, look ahead LR, and canonical LR, or simply just you can call LR. Everybody? Yeah, simple, look ahead, and canonical LRs. All are LRs. Yes. अरे यार, look ahead LR. LA means look ahead. चलो start कर लेते कहीं example से. Okay, let's come to the point. Okay, let me take one example to explain all of them. I'm taking intentionally a little bit lengthy example. That's okay, fine. This is one example. How do you understand this grammar is LR0 or SLR1 or LALR1 or CLR1? So before answering this question, let me give you diagram to remember the relations. Let me give you. Is that clear? First remember that diagram, yes, comparisons. Okay, let me help you first. We got LR0, SLR1 and LALR1 and CLR1. Okay, we have 4 classes. Okay, this one are all LR0 context free grammars, and this box all SLR1 grammars, and this one is all LALR1 grammars, and this one is all LR1 grammars. And if you want to know one more relation, that is unambiguous, I can make that here itself. That box name is all unambiguous grammars. This is all unambiguous. At any cost you remember it, but because you can save a lot of time if you can remember all this hierarchy relationships. Fine. Now let's talk about one important one, that is, there is one more. What is that? From Katak, Yatak. Anybody realize which grammar it is? Quick. That is all LL1 grammars. Clear? And now there is interesting fact here is, if LL1 grammars they don't have epsilon, they are going to be inside this side only. I can't tell you now, but if you don't have epsilons, null productions, all the LL1s are going to be here if they don't have null productions. Okay. Fine. This is enough for the exam point of view. So look at the diagram classification. Okay. Now remember, can I say every unambiguous grammar is LR0? True or false? Okay. I'm going to write 2 statements here. Please note down this and take a screenshot. I'm going for one question. What is the right thing? All LL1 CFGs are unambiguous. Is this true? Or all unambiguous CFGs are LL1? Which statement is true? 1 or 2? Which is true? Quick. And it's compiler, most of the questions are very theoretical points. Yes. Pratik, that is true. If LL1 grammar has no null production, it's going to be there in SLR1 class. Yes, you are true, Pratik. Yes. Which is the true here? Come on, guys. Please like the session. And also share with your friends, and you share with the group. You are there in many groups in Telegram and WhatsApp. Please share with your friends. 1 is true, 2 is false. Everybody agree? Cooking, 2 is wrong. Unambiguous CFGs, yaar. Unambiguous CFGs, no need to be. All unambiguous CFGs, no need to be LL1. Some. What is the right statement? Some unambiguous CFGs only. This is the true, because there is another true statement. Some unambiguous are also not LL1. Out of this four, this is true, this is true, and this is true, but this is false. Clear, everyone? Such kind of questions confuses in the exam because of lack of knowledge or lack of relationship. You are not aware of the relationship between all the grammars, right? Everybody clear? Such questions are going to save your time in the exam. You can easily secure. the marks. Yes, everybody clear this point? First, third, fourth are true and the second one is a false. Any doubt so far? Are you ready to see the LR0 example? All in one session. Okay, where is that example, guys? This one. We have two things to talk about. Okay, let me talk about something. In the exam, the options will decide how to check this grammar. Are you going to draw the LR0 diagram or are you going to draw the LR1 diagram? Tell me now. What are you going to do in the exam? Yes. Come on, quick. Are you going to construct LR0 diagram or are you going to construct LR1 diagram? Which one you do it? Quick. If I want to check the grammar is LR grammar or not, LR0 or LR1, because you have learned 4 grammars, right? LR0, SLR1, LLR1 and CLR1. Which one you draw in the exam? Remember my point. I've not seen any question that depends on diagram. I've not seen any question that depends on the diagram. I believe 90% the question doesn't depend on the diagram. LR1 की diagram जरूरत नहीं और LR0 की diagram भी जरूरत नहीं. Are you clear this point? Because such question should not be asked in the exam. That if they ask, it could have been very small example. You might have 2 or 3 productions. Are you clear this point? I don't follow any diagram. Options will help you. If in the options only LR0, SLR1 is there, then don't go for LR1. Why do you need LR1? When the options are not going to talk about, look at the options and decide. If one of the option is ambiguous, if the one of the option is none of this, and look at that, is that correct? Because sometimes if the grammar is ambiguous, then you don't need to draw any diagram. Are you clear? Let me give you an algorithm first before doing this. Let me give you an algorithm first. Look at CFG. In case you identified ambiguous, don't do anything. Because ambiguous CFGs they are not any type of grammars. They are not LR1. All of them, yeah. They are not even LR0, they are not SLR1, they are not what else, LLR1, they are not LL1. अगर grammar ambiguous है क्या जरूरत है diagram? Do you require the diagram? अगर exam में ambiguous grammar दिया, do you require the diagram? So don't waste your time if you learn it, right? Don't waste your time. Clear everybody? This is the first shortcut. अगर grammar ambiguous है, no need to check any diagram, whether it is LL1 or LR1 diagram you are drawing, you are going to get the conflicts. LL1, you are going to check the first and follow, you get some conflict, that means some kind of not equal to empty, right? Please don't do that. Conflicts coming, Lata Sharma, I'm coming to the conflict. Okay, unambiguous CFG. Alright, don't worry about which I have not discussed yet. Keep asking about. If it is unambiguous, there are 2 problems. Look at the options. If it is LR0, over answer. If it is LR0, then no need to check LR1, SLR1, LLR1. The reason is, if it is LR0, it's going to satisfy SLR1, it is going to satisfy LLR1, it is going to satisfy CLR1, but LL1 check separately. Clear? Everybody? Can be, Kumar, can be. I can't say, right? Not always. If not a CLR1, it means it is also not SLR1, it is not LELR also, even it is not LR0 also, even it is not LL1 also. And other than this, you have to work little bit. Other Take time to answer. Take time to answer because you need to draw the diagram. Everybody, DFA banana nahi pehle. Yaad rakh lena, in the exam, they don't ask you to draw the diagram. No, Sristri, LL1 is not a subset. LL1 is not a subset of CLR1. LL1 class is a subset of CLR1 class. Do you agree, guys? LL1 matlab kya? Is it grammar or class? Grammar subset nahi hota. Class is a subset of CLR1 class. Come on. Clear, Sristri? We don't say subset. Grammar को subset नहीं बोलते, class को subset बोलते हैं हम. All right. Okay. वो भी बताता हूँ यार, गलत मत लिखना कभी भी. LL1 is or LL1 CFG is LR1 CFG. इतना बोलेंगे, ये मत बोलना LL1 CFG is subset of. गलत हो जाएगा. It's wrong. यार इतना तो पढ़ना आना चाहिए यार. ये फर्स्ट है, सेकंड है और थर्ड है. सेट ऑफ ऑल LL1 CFGs is subset of LR1 CFGs. ये जो सेट आता है ना यहाँ पर, वो सबसेट होगा पक्का. This is true, this is true, but this is false. इतना तो पढ़ना आना चाहिए यार. कंप्यूटर साइंस वाले यार, सबसेट्स इज ये दोनों अलग होता है दुनिया में. एवरीबॉडी, क्लास के लिए ये तो क्लास है. LL1 class is a subset of LR1 class, but LL1 grammar is not a subset of that, right? ये इतना तो आना चाहिए यार. We are कंप्यूटर साइंस स्टूडेंट्स. is subset दोनों अलग वर्ड्स होता है. is अलग है, is subset of word अलग है ना? Everybody clear? Come on. ये TOC में तो यही तो पढ़ाया था ना, right? So please try to use the words carefully. Okay. चलो आगे चलते. Okay. Now let's come to the point. Depends on the option. Are you going to draw the diagram or not? Yes, depends on the options only. Now I have not given the option, so I will go to one thing. कुमार, एप्सिलॉन तो नहीं दिया ना. आपके डाउट है तो प्लीज आस्क ऑन द ग्रेड अप ऐप. इंस्टॉल द ग्रेड अप ऐप. आस्क द डाउट टुडे only will get a reply. Kumar, post your image on grade up and today night itself I am going to reply to your doubt, but tag me. Yes. Okay, now look at this question. If you are going to draw the LR0 diagram, you can answer two things. LR0 you can answer, SLR1 you can answer. If you draw the LR1 diagram, you can answer LLR1 and CLR1. Because LR1 items will help you for LR1 and LLR1. LR0 items will help you for LR0 and SLR1. So it is your choice which one to draw. Depends on the option only you are going to decide. If I am going to ask all the grammars, then this diagram is best. Because here every answer is there. But if I am asking only about LR0 and SLR1, this diagram is enough. Because I don't need to draw lookouts and this takes much time, yaar. है ना? Clear this point? Yes, Vinay Kumar. I am worried so much than you. Remember that? Every topic I want to cover, even 3 hours also, I am putting much effort to cover every concept which is there in the syllabus. Do you agree or not? Almost every concept I am revising you. Do you agree or not? Whether it is 170 or 100 or 1 person is watching my class, because I am teaching what is needed for you. Everybody? Come on, Lata Sharma, please don't disturb the class. है ना? Right, I am not here to resolve your doubt, remember. I am here to complete the whole compiler revision. Yes, please give response. Your response only makes me to revise even code optimization whole also. Right. Come on guys, please like the session. If you have not liked it, कंटिन्यूसली यार 3 घंटे बात कर रहा हूं आपके सामने, 3 घंटे, है ना? I'm going. Can't, don't worry about it. Even I need some time to balance myself, right? That is the reason I always communicate with you in between the class, right? I just want to see how many are actually, interacting with me. Your words and your, the text is going to help me to teach better and better. Yes, just say yes. Even you say no, I welcome you guys. Even you say no, but I expect everybody says yes in the class. Thank you so much. Thank you so much. Okay. While we teach, my focus is always on what you ask, because your doubt is my response. Remember that? When you ask your doubt, I always look at your doubt, I will make you correct. So I want you to interact all the time, whether I answer or not. If I take that answer, your doubt will be cleared. Is that clear? 99% of your doubts will be cleared in my class. I don't know how many of your faculty are going to take your doubts, but in my life, I respect every student who asks the doubt, because I learned from the students, so I'm giving back to the students. Yes. Yeah, Pandey, keep on asking your doubt. I will take in one time, right? After some time, I'll take your doubt. Keep asking your doubt. Okay, how to draw the LR0 diagram? बहुत easy होता है ना diagram? S dash derives S. This is how we begin diagram. Everybody agree? Okay, let me start. Let me know, is it visible properly? Let me know, is it visible properly? Right, this is how we begin. Yeah, looks like not visible properly. All right. Okay, because of this S, we are going to write all S productions. There are 3 S productions, dot SA or dot SB or dot C. And here again you have S. We don't write again because S is already covered. Here C is there. This is a terminal. So this is initial state of the LR0. And S, if you read S, you get all of them. If you read C, only will get one. That is S derives C dot. And now when you read S dash derives S dot. And all of them, it moves dot after S. That is S dot A or S dot B. And after dot, there is no symbol after dot A, after dot B. So you don't have any non-terminal. So we just make the closure or complete closure. And here you will have A, one item, no need to write. You have a B, one item, no need to write. Why we don't write one item in the diagram? Because to save our time. To save our time. Everybody? Yeah, white is better? Alright. Clear? And one item, please don't write, because one item will never create a conflict. Now look at here. Is this reduced item? Yes. But is it shift item? Yes. But this reduced item never participates in the conflict. How many of you remembered the S dash to S dot? S dash derives S dot never produces a conflict because it is acceptance item or never participates in a conflict. Everybody, even though it is reduced item, but it is acceptance item. We call it as acceptance. So we never look at that item to produce a conflict. So here only we have a shift item, but there is no reduced item that can produce a conflict. We say here no conflict. We say no conflict here. So this grammar is LR0. Here if you look at, there is no reduced item. Here reduced item, but there is no other reduced or other shift. Yes, so this grammar is LR0. If it is LR0, do you require to draw the LR1 diagram? No. Do you require to check SLR1? No. Is it clear? Yes, it is, but you don't need to write a dollar for LR0 diagram. Who is that? Parek, dollar is there, but no need to write dollar here. No need to write dollar here, because that is not going to change the answer. All right, everybody. But if you want to draw LR1 diagram, let's look at what is the difficulty. Let's look at, if anybody forgot the concept, let me help you. We will start with dollar, and because of this S, you will write all S productions, and you have a dot in the beginning. Copy all the three items here as it is. You will get SA, but you are covering this S. Don't forget that. Copy all of them, and for all these three productions, who is the lookhead? Who is the lookhead? Who is the lookhead, guys? Quick. Who is the lookhead for this three? Yes, it is a reduced item, Shukrut. It is reduced item. S derives A dot is reduced item. This is the only one which is not reduced, because we have taken, we have added, it is not there in the given grammar. This is we have taken to accept. This is we have taken to accept. This is not there in the grammar. That's why we don't make it participating in the conflict. We don't keep in the conflict. Acceptance is reduced, but it is not equal reduced. Yes. Yes, correct. It is not equivalent to reduced. Reduced word we use for other than the acceptance, but one of the item is acceptance. Special. What is it? Dollar. Yes. Now, let me help you. Because of this S, I need to write all the three S productions again, but I don't write, because I know their follower is A, so I'm going to keep this A in all of them. Everybody understood? Instead of writing all the three items again, I can directly copy the A, all of them. And again, this S is also says that my follower is different from others. That means that B, I need to write again all the three S items. I need to keep the B. Instead of writing again, what I do is I will keep B for all of them. And after C, of course C is not a non-terminal, so no problem at all. Did you understand why did you get $AB there? Because there are three S immediately after the dot. Did you see that? This S and this S and this S. There are three S, so we got three different followers because of that. Yes. Come on, quick. All right. Yes, Mahmuda. All right. Everyone, I will avoid choosing the pink. Come on, don't worry about it. I want to differentiate. Fine. Now, read S. You get three ones. There's three productions. One is S dot. Other is dollar or A or B. Other one is S dot B. And that's it here. And if you read a C, you will get 1. If you read A, you will get 1. No need to do that. If you read a B, you will get a 1. Any conflict? Again, no conflict. Already it is LR0. But why I'm doing this? Just to make you revise. This is LR1 diagram. Yes? Come on, quick. Right? They might ask in the exam, I naught is equal to closure of S dash derives dot S, and they might ask how many items are there in go to I naught comma S. What is the cardinality? Yes, can you answer that question? I naught, they defined closure of S dash derives dot S. and how many items are there using LR1 and using LR0. In LR0 we got 3 productions, in LR1 also we got 3 productions. Everybody, can you see that? They may ask how many items are there using LR1 or using LR0. Mostly they ask LR0. Clear? Everybody clear how to answer it? Why dollar in look ahead of S? Because of this S you have written 3S now. Then this dollar is going to be included. Come on yaar. Abhi nahi padha dunga main. I'm not teaching this LR1 construction. I'm not teaching you guys. ये घंटा लगता है ये टीच करने के लिए मुझे. Why dollar is included? Basic definition है. Because of this S, you are writing this dollar to all S productions. Because of this S, this A you are writing in all of them. Because of this S, B you are writing in all of them. वो S को समझना पड़ेगा ना. There are 3 S, तो इसलिए आपको डॉलर 3 में आया है ना. ये 3 में आया, B 3 में आया यार. All right. पढ़ो बाद में पढ़ो यार. Basics. Okay, I hope you understood. Now let's go to the conflicts revision quickly. Yes, before going to the operator precedents, before going to this, let's go to the conflicts revision. Which color I can choose? Let me do that. Yeah, conflicts checking. Whoever forgot, let me revise. Conflicts. We have 2 types of conflicts. One is SR and other one is RR. Shift reduced and reduced. There are 2 conflicts. So if I am going to talk about LR0 conflicts, there are 2 types. Even SLR1, there are 2 types. And CLR1 and LELR1, you can use the same principles. Diagram only different. Okay, you can remember this. Yeah, ये मत पूछना what is SR and what is RR. Don't ask me what is SR and what is RR. है ना? चलो. White color is the best. All right. चलो 2 घंटे हो गए यार. 2 घंटे 240 likes and still 150 nearby people are watching on live. Great. Okay. Why we say SR? If any state has both shift item and reduced item, we say it is SR conflict. Everybody clear? That's all. कुछ check नहीं करना. क्यों? LR0. 0 means I don't have any knowledge to check. Just I look at this item is there, shift item, reduce item, it's gonna be conflict. And what is reduced? If any state has both reduced items, there are 2 reduced items, at least 2 you can say. You can say at least 2. Okay, but when it comes to SLR1, okay, if I have something here, x derives alpha dot tb, this is shift item. Let's say this is reduced item. Shift item, reduced item. So how do you check the conflict here? How do you check the conflict, guys? Quick. How do you check the conflict? This terminal you are going to check, is it present in follow 5? If T belongs to, not belongs to, no problem. If it is belongs to, then it is a problem. Follow of Y, then you get a conflict. Everybody agree? Everybody agree? If this terminal present in the reduced item follower, then it is a conflict. Here there are 2 reduced items. यार ये तो बहुत मुश्किल है पढ़ाना without any concept. Those people who don't know this concept, better to avoid in the last minute. I am going to give you one suggestion. If you have not studied this, please don't go beyond this. Okay. Alpha dot and y2, let's say alpha dot. Both are reduced items. Both are reduced items. So what do? Both are present in the same state. You are going to check follow of x and follow of y. If you get not equal to pi, then not equal to pi, remember not equal to pi, then there is a conflict. Yes. Okay, what about this CLR1, LLR1? It's very easy, very easy. There could be possibility of the question directly from this table, so you can remember if you want it. And I'm just writing L1, and other one I'm writing, let's say alpha dot or gamma dot, is your choice. So what do you look at here? What is the rule to check? This T, just check here. If T belongs to L2, then it is a conflict. Then it is a conflict. X2 alpha dot, Y2 alpha dot, but there is L1, there is L2. Then how do you check it? Quickly guys, don't go away, don't go away. After this we have again theoretical points. L1 intersection L2 not equal to pi. है ना, इस table को याद रख लेना guys. This is gonna be difficult only when you don't practice. If you are already practiced, you can easily recall the concept. I can see that 20 people are down because they don't know about it, right? So I will avoid writing such questions when you don't aware of it, when you're not aware of it. Yeah. So have you remembered all these concepts? Come on, quick, quick. I don't want to use this kind of concepts in the class revision. Anyhow, I did it. And parsers, grammars and languages all are different. Parser is the combination of many things, and grammar is a set of productions, and language is a set of strings or a set of you can say a token, set of tokens here in this compiler. Here parser is actually many components. This is a parser guys. Input, here you have a tokens. अभी तो बताया T1, T1, T2 कुछ ऐसे example. And you have a parsing algorithm, you can say control, and you have a stack, and you have some table where you have implemented before implementing the compiler, and this all together is a parser. And what is the grammar? You write grammar something, right? It's just set of productions like alpha 1, alpha 2, beta 1, beta 2, beta 3, something like that, or gamma. This is a set of productions. And what is the language? Is a set of tokens. I may write T1 or T1, T2 or something like that. So understand the concept. Understand the concept. All the three are different. All the three are different. Then what I want to do here, in the exam there are so many questions on these parsers and grammars and languages. Everybody clear? Parser is the combination of stack, table and algorithm, and grammar is set of productions, and language is set of strings, you can call strings. That strings we call tokens in this chapter. Tokens in this chapter. Are you clear? Yeah. So let's move on. What we need among this, let's look at the parsers. We have very interesting points. First point, look at the parsers. Look at the parsers. LL1 parser is less powerful than LR1 parser. Everybody agree? And not only this, LR0 parser is less powerful than, come on guys, direct questions. Have you seen there are 2-3 gate questions are there only on this relation? There are 2 to 3 gate questions are there in this relation. Agree? Come on, continuously teaching from 2 hours. Come on, come on. If you want a break, you can take, but let's complete this session. Yeah. What else you have apart from that? Grammars. What is the relationship among the grammars? If you look at grammars, LR1 grammar is LL1 लिख लेते हैं. LR1 and set of LL1 CFGs subset, of course equal not required, proper subset, no doubt, set of all LR1 CFGs. So this is the main relation between. So if you want to relate all of them like this, I can relate set of all LR0 CFGs is subset of SLR1 class, assume that LALR1 class, don't say grammar, say class. Either strictly subset or equal, both are same. Everybody, this is what you need to remember for the exam point of view. What do they say? Yeah, thank you so much, Kushwaha. Yes, I need water, and thank you so much for reminding me. Yeah. Third one. Languages. So when you are comparing the languages, same, but you write set of all LL1 languages is strictly subset of LR0 we write, then LR1 we'll write LL1 later on. Set of SLR1 languages similarly you can write LR1 later on, and also you can relate. There is one important relation between TOC and compiler. What is it? Set of LR1 languages, nothing but set of all DCFLs. If you are not aware of this, and please remember, set of all LR1 languages, nothing but set of all DCFLs. Yes. SDT concepts also will be covered just after this. Yeah, good evening, Megha. Good evening. Come on. One after that. You need to go for, SDT means first you complete syntax, yaar. Syntax ही खत्म नहीं हुआ अब तक. All right. Quick. है ना? Chalo, let's move. Operator precedence relations. Just I want to remember 3 relations here. We have, look at A plus B, and A gives, let's say, C star E, and assume that B gives something like F. Look at what kind of relation is there, plus and star. This is a kind of model question, guys. True, Sachin, true. It is not possible, it is always Sachin. Here, doubts? What kind of relation between a plus and star? Come on, quick. How do you understand? Look at the diagram that you make between plus and star. Look at these 2 examples. A plus B, and A you have C star E, and B you have F. Look at carefully between, very simple question. Look at this plus and look at this star. Which one should be evaluated first according to the grammar? If you are writing this input or this program And how this compiler is going to understand your program? Who has more precedence? Star has more precedence. Everybody, can you see that? In the exam, they might give the grammar or they might give the parse tree. But parse tree, if you are able to realize the parse tree, answer is gonna be easy. So star has more precedence than plus, and plus has less precedence. Clear this point, everybody? But star has to come left side, not the right side to the plus. Both are different, guys. Star should be left side to the plus, because in the grammar, from capital B, star never comes. Okay, don't blindly say star is higher precedence. Yes, star is higher, but that should come to the left of the plus. That should come to the left of the plus. Remember that. Everybody, star has more precedence than plus, but that should come left of the plus. Yes. Okay, that's one example I can give. Second one. E derives A plus B, and A gives F and B gives C star E. Now tell me, who has more precedence? Who has more precedence now? This time, come on. Who has more precedence? This is what in the exam, right? The questions are there already. Just I'm making the revision, that's all. I'm going to the point that is required for the exam. Remember that. अगर ये समझ में आया ना, exam में you can apply for any grammar. I'm directly going to the point. Now, who has more precedence? अगर आपको logic समझ में आना चाहिए, just construct the parse tree. Okay, ये है. Relation क्या? You need plus as well as star. Star किस side पे आएगा? Right side पे, ठीक है. ये एक example है where plus and star both are there. Now, which one is considered more precedence, plus or star? Without evaluating the star, can you do the plus evaluation? First star should be evaluated, means again star has more precedence. Now plus has less precedence. But ये कैसे हुआ? And star has to be only right side. Now this time star cannot come left side. Look at, from capital A, star never appears, only F appears. So star should come only right side, and that should be evaluated first. Everybody, same answers. The previous example, this example, answer is same. Only the difference is here the star comes after plus. If you write the example, F plus C star E. Previous one, the star comes before plus. Here this is evaluated first, then this one. In the previous example, the input is, you can see the input is C star. This is one example which can talk about the relation between star and plus. This is the relation, right? Star never comes after the plus in this example. Yeah, associative is different. Let me come to that. Associative, look at this. E plus A or B. Now, which associative it is? Quick, which associative it is? If you are going to write 2 plus, how the second plus comes from this parse tree? Only from here, right? Okay, assume E ends, or you might have some other input. It's okay, fine. Now, when I am comparing this 2 plus, which plus is evaluated first? Left plus or right plus? Is that left plus or right plus? That's going to be associative property. When you have two same operators, which operator is evaluated first? Left operator or right operator? If it is evaluated left first, that is a left associative. If it is right first, that is a right associative. Here, the left plus should be evaluated first. Then right plus. That means the left operator has more precedence and right operator has less precedence. So this is called as left to right associative. Plus is left associative or left to right. Everybody agree that? Yes, left first means left associative, no doubt about it. Okay, if you want to do without recursion, this is a recursion, left recursion, so we got left associative, and sometimes no recursion. Look at that, sometimes no recursion. Now this time there are 2 plus, only 2 plus, look at that, E plus, there is no possibility of third plus here, but still you have a relation. When you get a 2 plus, which plus is evaluated? Again left, but there is no recursion here, right? Understand, when you have a left recursion, definitely left associative, but left associative doesn't mean that left recursion. Here also left associative, but did you see any left recursion here? No left recursion. So this is the most important point for you. Good evening Dipankar, good evening guys who joining late. Yeah, still we have reached again 150 guys. I'm aiming to reach 200, at least tomorrow we should reach 200 or even 300 only. That is possible if you are sharing this class with your friends guys. Please share and also ask your doubts on GradeUp. And you know, there is one platform where many people are aware of our doubts, and please share your doubts on GradeUp app if you are already on the GradeUp. Okay, now this plus is evaluated first and this plus is second. That is, right plus is evaluated later, left plus is evaluated first again. So here also plus is left associative. Everyone, it's so easy guys. Those people who are finding leads and trials, they take much time, but this is going to be very easy for you. This is right, this is the left. I'm going to, when I'm explaining left, I will also explain right. Dilip, don't be in advance, don't be in advance. Okay, you are so advanced compared to me, I can't bear you, yaar. Okay, look at this here, look at this. Now which associative it is? When I am writing something here, A plus S, how do you get other plus? Is it from left or right? Is it from left or right? From this S, I get another plus. And don't worry about that S. S gives B, that's okay, fine. Now focus on 2 plus. Try to get somehow this plus. Yes, I got it. This is the left plus and this is the right plus. And tell me which one should be evaluated first, right plus. So this is called as right to left associative. Here we call plus is right to left associative. Clear? Everybody? Come on, come on. And we also have, without right recursion. This is a right recursion. In the exam, if you see the right recursion, say right associative. Right to left associative. Even though sometimes it happens, without a recursion, it is possible to have associative. Yes. Is this right recursion? So right associative. Very easy, very easy. But without recursion also possible. What is the example? Very simple. As A plus A. Look at this. When you have 2 plus, the second plus comes from the right side. Yes, A plus A, B plus C. Look at this 2 plus. Compare this 2 plus. Now again, right plus should be evaluated first if you want to evaluate left plus. Here also plus is right associative. Clear everyone? That's all I can tell about left and right associative. In the revision, I can't teach more than this association concept. Right? Precedence rules have explained associative and equal precedence also there, but I have not taken. I will take one example for that. If you have this example, now look at the left is equal to right, but right is not equal to left. That is the difference. Left is this one, left to parenthesis and the right parenthesis. You can write all are at same level, all are at same level. Look at that, all are at same level, all are at same level. So you can say this is equal to, let me write something to end. and I can say this is equal to that. But also look at this one, when you have a table, the left and right parenthesis you should write equal. But when you have right here, your left parenthesis, don't write any relation here. Because after right, do you get a left? Left never comes. After right parenthesis, left never comes. So here no relation. You write here error. Nobody can ask after right left, because in this grammar there is no left parenthesis after the right. Everybody? Yeah, thank you so much. Thank you so much for joining this session, guys. But also I need many likes in this session, and also share with your friends. Yeah, I asked the water somebody, but not yet brought here. All right. Chalo, clear everyone? Fine. Okay, this is what we have on GradeUp right now, February Mela, where you can win exciting prizes by participating and subscribing to this. And please participate here and get prizes if you are interested, and join GradeUp Super to get the benefits of all of them. All right. And this is also gives, this Mela also gives, like you have a validity of something like 7 plus 7, you pay 12,000 instead of 24,000, and 9 plus 9 validity like 16,000 instead of 32,000, and 12 plus 12 validity is going to be 20,000 instead of 40,000. And this double validity, that means you are going to get double months validity when you are going to purchase for something. Yeah, so it's just like 50% off on GradeUp Super, and you can prepare all the live courses and live mock test, as well as you have, apart from ESC and GATE, you have so many batches on GradeUp. You can join GradeUp Super if you are interested to prepare with us. Yes, I'm at GradeUp office. I'm going to work from GradeUp office. Yes, I'm not at home right now. Yes, all right. Now, yes, take a 5 minutes break. We'll join after a few minutes, guys. I'll be on live. Yeah, just take 2 to 3 minutes break. I'll be coming back. Don't go away. If you want to discuss anything, please let me discuss with you. Don't go away. I will be here. Yeah, just take some gap. Continuously we are learning something in the revision. It is online. Yeah, online or offline? Sumit, what is it? I'm teaching on YouTube, right? Yeah. All right. Please try to interact with me. That makes your learning, which is useful for you. Yeah. Yes, Noida, Bartindu, right? Sristi, I'm waiting for water. No, 15 minutes. In few minutes, I'll be starting once I have water. Water चाहिए.
सर पानी
कहीं पे नहीं.
पानी के लिए पेंट्री बॉय चले गए.
Okay, all right. Bad news is that we don't have water now. All right, how to control nervous? Rishabh, if you are really studied, obviously you will face kind of fear, but it's not nervous. Don't convert fear into nervous. Yeah, you should have fear because you are studying hard, you're studying from long time. That might be the reason you are getting a fear, but don't make it nervous. Yeah. Good. Kushwaha, right? She's good now. I don't, right now I'm not teaching offline at all. Thank you Sonu. Please arrange water for sir. Good Ali, thank you so much. You are the one that you are making me great. Yeah, thank you Nishu, thank you. And I'm only visible from I'm teaching online from the last 1 year, but we work very hard for the students. As students learns a lot to get the ranks. Yeah, thank you, Chandravanshi. Yeah, for everyone, it is Happy Valentine's Day. But we have the GATE exam on Feb 13. You can celebrate on Feb 14th. Yeah. निशु कुरियर कर लो यार, है ना? All right. देखो ये सारे efforts, this all efforts that I'm doing only because we are having exam very near, and you should not fear, because why I'm coming to the online, I don't want to come to the online these days. I don't want to waste your time. I'm only coming to save your time. If you are coming to my session, that means you are making the revision. Yes, I will involve in net too. Thus, if it's any batch is going to launch about net, I'm going to take the classes for that on Grade Up. Yes. Thank you, Tammana. Yes, we should never remember the formulas. What we have to do is, the formula should come automatically when you learn the concept. Those people who are remembering the formulas, we are not going to survive in the exam. Remember my words. After my MTech, I have written the exam once. I only try to remember the formulas just before the exam. That is, I think, how to compute onto functions. I tried to remember the formula just before the exam, in the exam that came, but I was not able to answer even though I just remembered before the exam. Still, that is the problem that we face when we don't understand. The formulas are not going to help you even you try to remember. Because of the fear, because of the nervous, the formulas are going to be deleted from the mind automatically. But those people who practice a lot, sometimes you can remember. It's not all the time, sometimes. Yes. Thank you so much. Yeah, it's a fantastic. That means you are enjoying, you are learning. That's great. All right, Das, it's your choice. Yeah, Divya, it's not yet scheduled my classes. I will let you know. Dipti, when discrete mathematics? Tomorrow, day after tomorrow, discrete mathematics revision is there. Rambabu, yes, there. Day after tomorrow. That is, I only made because in the last session somebody was asking, sir, we need discrete mathematics revision. So I have planned day after tomorrow discrete mathematics revision. Yes. Okay. In the break also, you are not allowing me to take rest. That's good. You are utilizing the maximum. It's just like, Geo. When the Geo is launched, it looks cheaper, right? They have given completely free, right? East-West. Ask the Geo, why did they offer everything is free before launch, coming to today's scenario? Today, are they giving the free network, free internet, free SIM? No, right? It's everybody. Even Grade Up is going to be costlier when we are on the platform. Remember that today we have a very good platform. Just we have to be we have to be in the competition. Definitely the Grade Up is costlier than anybody, but so many people don't realize that. Geo is also similar to that, right? Of course, Grade Up has very good other benefits like asking the doubts and clearing doubts by mentors. These are the many benefits that you have on the Grade Up. Yeah. Yes, I have Garima. I have taken so many. Yeah, all right, Tamana. You are not aware of my classes. I used to teach continuously 9 to 10 hours with very few breaks, and water is only for temporary, right? I can drink water, even 2 to 3 liters of water after this class that I'm going to do anyhow. Let's continue the class, guys. Semantic analysis. This is not the SDT, it is a semantic analysis. What is semantic analysis? How is different from lexical analysis? Okay, let me tell you. Lexical analysis, syntax analysis, and semantic analysis. In the lexical analysis, we recognize tokens. We recognize tokens. The main purpose is, yes, and syntax analysis is going to understand the syntax of the program by producing the parse tree or whatever it is, by producing the parse tree. And semantic analysis is going to understand the semantic by producing the semantic tree, like annotated parse tree. So what is the example? Tokens means like int a and semicolon, something like that. There are three tokens. Int a and semicolon. But when it comes to syntax, we have int is not actually int now. It is converted to some token frame T1, T2, T3. It's just like a string now. This is a T1, this is a T2, this is a T3. And semantic, it's going to understand beyond the syntax that A is a type of integer. So it's going to make an entry into the symbol table. If semantic analysis is going to run on this syntax, then it knows that in the symbol table, the A should get the type integer type. So it's going to make an entry into the symbol table when it looks this declaration. When it looks the declaration, there will be symbol table for A. It's just like, what is A here? T2. T2 was made by lexical analysis, and maybe let's say it is a line 10. Let's say line 10. Okay, I'm just writing it as a line number 10, and the type which is gonna be integer. Okay, the T2 may be made an entry by lexical analysis, and line number may be syntax analysis, and type might be by semantic analysis. So this is how it's gonna be working. All right, everybody. What is the semantic analysis? And let me help you. What we are going to do. In the semantic analysis, there are so many things are there. We can use SDT, of course not compulsory, to perform semantic analysis. Even you can use linear bound automata. For that. And if you look at examples like type checking of expressions, or you can go for declaration and its use, declaration of variables, and its use, you are using but not declaring, then semantic analysis is going to generate an error, semantic error. And the function compatibility, you are passing two parameters, but we have only one parameter in the definition. It's going to generate an error using semantic analysis. Such you have so many things to generate in semantic analysis. Yeah. Yes, type checking is one example, and other example is you are using it but not declared anywhere. Yes, not PDA, you can use linear bound automata, because PDA cannot understand the meaning, it can only understand the structure. PDA can only understand the structure. Yes, it can be used for type checking. Yeah. Dilip, that is why I am doing the revision for you, Dilip. You are able to learn the new things, but I am here to make you revision. I am not teaching anything here. Did I teach what is type checking? Did I teach what is declaration of variable and its use? No, I am only helping you to revise. This before the exam, I can't teach anything new. Remember that. Alright. Now come on guys. And now I am going to help you what is SDT. In this SDT, please learn attributes. Very interesting GATE questions. Second, learn definitions of SDT. Third, evaluations. So these are the three important topics in SDT. And if you look at the previous year GATE questions, they have given definitions and they have missed some points and they asked what is the answer for that. Yes. All right. जल्दी डिलीट किया कन्हैया कुमार, हिंदी में चाहिए, जल्दी डिलीट किया यार, क्यों, मैं तो पढ़ रहा हूँ ना. Come on, come on. So what are the attributes you have? We have two types, inherited and synthesized. Yes or no? How many definitions for SDT? We call syntax directed definitions. We have two types, S attributed grammar and L attributed. Oh, I'm sorry, I'm using pink again. Okay. And why it is fine, looks like. And evaluations are many, depends on we have many types, like if it is attributed SDT, then you have two types like L attributed evaluation, we have S attributed evaluation. But here no restriction, if no attributes, no attribute computation, in case no restriction at all, you can create your own evaluation technique. Okay, this is the important one where people might require to understand more. When you don't have any computation of the attributes, no restriction, how do you evaluate? I can ask how to evaluate, you can follow that. Yeah, clear? So what is inherited and synthesized? Just we'll take one example, we'll go quickly. In the revision we are not going to worry much. We have two types. We don't focus on the grammar, we focus on attribute. Suppose you have a production and you have something like this, and I can, if I am computing, let's say A dot X is equal to, I can depend on parent or I can depend on even sibling. But right sibling is fine, because I'm not talking about definition of a grammar, right? In the definition you can't use right sibling, but this is an inherited attribute. This is an inherited attribute because I can use the parent or left sibling. Look at that, you are computing at A, here we are computing at A by depending on its parent and by depending on its sibling. Look at that. It's depending on its sibling and parent. Of course, right sibling fine, because I'm not talking about definition of a grammar. If it is L attributed, it can't use right sibling. But I'm not talking about L attributed, S attributed. I'm talking about what is the attribute. What is the attribute is different from what is the grammar. Everybody? L attributed grammar is different, inherited attribute is different. It's talking about attribute. Here inherited attribute says that computation depends on, this is the computation. At any attribute depends on either parent or siblings. But there is no grammar at all. I am just talking about one production. Here synthesized attribute. Suppose you have SAAB. Here I am going to use something like S dot X is equal to A dot X divided by B dot X. Even I can use B dot Y, that's fine. I am computing at somewhere, I am computing here by depending on only children. If computation is happening by depending on children, that's called as computation is happening here by depending on its children. then that is called as synthesized attribute. Is that clear, everybody? It's a very simple definition here. If you are computing at some place by depending on its children, then that is called as synthesized attribute concept. If you are computing at some place by depending on parent or sibling or and sibling, it's your choice, then we call it as inherited attribute. Okay, they might ask what kind of attribute I am using in the grammar. Then you should answer properly. Come on, guys. Okay, now let's go for definitions. These are different. What is the difference? Let's look at. If I am going to talk about S-attributed grammar, S-attributed SDT, definition, SDT, all are same, and L-attributed definition. How is different from the attributes? In attribute, we will focus only on particular production, and that concept we are going to apply every production. But here we look at whole grammar. Suppose I have given a grammar. Let's look at this one. Look at this one. Look at this grammar and try to understand the definition. There are two concepts here. I need to look at whole grammar. I am not going to look at just one attribute. Here I may have more than one attribute, but I have only one attribute. I am computing at S by depending on its children. I am computing at A because left side of assignment, that is LHS, L value, is called as a computation. That depends on evaluation. Aryal, ये तो समझ नहीं आता, ये evaluation नहीं है. Evaluation is another topic. क्या समझ नहीं आता? Near, मैं evaluate नहीं किया यार, मैं definition बता रहा हूँ, evaluate में जा रहा है. इतना जल्दी क्यों यार? यार एग्जाम ही नहीं लिखा है, एग्जाम की रैंक आएगा क्या? बताओ ना. Right? Why are you worried about evaluation now? चलो, मैं ग्रामर के definition बता रहा हूँ, पहले इसको समझ लो. You are computing by depending on its children, and B तो computation ही नहीं चल रहा है यहाँ पर, चलेगा. And look at in every production the computation depends on its children or not depends on anybody is fine. Then everybody, then we call that attribute is synthesized. So I can say here X is synthesized, but I don't know grammar yet. Now this grammar is S-attributed grammar if every attribute is synthesized. Yes, every attribute is synthesized and all the productions are at the end. Are they at the end of the production or not? So that grammar is called as S-attributed SDT. This is the first point. And second point, translations are at end. All translations appears at end. Clear? Is that true? All translations are appearing at the end. Yeah. Thank you so much. Thank you so much for liking this session. Yeah. What about L attributed? Quick. What about L attributed? Okay, look at now. Please tell me what is attribute here. How many attributes are there? There are two attributes. One is X, other is Y. And in the first production, we are computing what? We are computing X. That is, at this place, we are computing by depending on its left sibling. And here we are computing here by depending on no one. I'm not depending even at A. I'm just depending on no one. So A can calculate directly without depending on anyone. So this can appear in both of them. right? It can appear like inherited, it can appear like synthesized. It's fine, it's fine. Yes. Now look at this. Translation is not at the end because still A is there here. It is at the end, it is at the end. So translations are not at the end. So what is the first rule? Attribute computation, even same attribute also you can do. Computation can depend on parent, even children, left sibling only, because this parsers, those parsers who uses this grammar, they follow only from left to right scan, so they only know about left sibling. And second, translations can be placed anywhere. You don't need to talk about translations. Okay, remember this. Clear, everyone? All right, got it. Okay, yellow color is not visible. Pink on green, yellow on white, not good. Fine. Over. Yeah, we have 15 minutes left and we are about attribute grammars. Now let's move on. Evaluations. As I said, I'm only making you revision here. If the grammar is attributed, then we have two kinds of evaluations. You can always follow L attributed grammar definition, that is L attributed evaluation. The reason behind it, every S attributed is L attributed. So even though it is S attributed, you can call it as L attributed. That is the reason, if the grammar is having attribute computation, just blindly follow L attributed evaluation. No need to follow the bottom up parsing S attributed concept. But if it is not having attribute computation, so remember these words. You can use, depends on the question. LMD evaluation is different. There is a top-down parsing. Even reverse of LMD also I can create. So this is the one where less number of people understand about this, because I am not teaching now. I am only making you revision. Reverse of LMD, RMD, reverse of RMD. I can create my own technique if I want it, but anyhow I am not creating. L attributed evaluation. Even I can create reverse of L attributed. अगर नहीं पढ़ लिया ठीक है. Yeah, there are so many evaluations in the world, so many evaluations, but I can't help you now because that takes at least 2 to 3 hours to explain this concept. To explain, yeah. लवजीत अभी ज्वाइन किया क्या? When I have covered so many code optimization techniques, now this is not the time to solve the problems. I am not going to solve the problems for the code optimization today. Right? If you have any doubts, please post on the grade up. I will solve for you. All right. But I will try to give some example for that. Okay, those people who want to evaluate using those techniques, please learn what is L attributed evaluation technique, what is S attributed evaluation, and what is LMD, RMD, all of them. You need to practice a lot. Yes. Now let's come to the intermediate representation. I will try to give some of the code optimization examples, but I can't help you in depth. Okay, in intermediate code representations, you have two things: linear representation and non-linear. And please let me help you. What is linear? Like you want to write a postfix code. that is the linear representation, and you want to write 3 address code. Even you have one of the special 3 address code, that is SSA form. And these are the linear representations in intermediate code representations. And in non-linear, you have like syntax tree, a special tree to represent intermediate code, and directed acyclic graph, one of the special syntax tree. And the third one is like control flow graph, also you can use, but which is a combination of the 3 address code and a graph, the control flow graph. And not only this, there are so many examples in the world, even 4 address code, 5 address code, 2 address code, you can have lot. But these are the standard representations of intermediate code, standard representation. Okay, so try to revise them. I'm going to make you revise with a few examples. Okay, fine. Let me take one example for that. Okay, I have an expression like x is equal to a plus b star c, very famous example. What is the postfix? First you need to evaluate multiplication. So b c star, one component, one operand is going to get after evaluation. And next plus is going to evaluate, so a and plus you keep at the last because operator. This is the next evaluation. And equal to, you may keep it or you can ignore it, is your choice. So answer is x a b c star plus equal. Everybody clear what is the postfix code? Yeah, that's very easy. You might be studied in data structure too. And if you want to write 3 address code, okay, first you may calculate T1 is equal to B star C, and T2 is equal to A plus T1, and X is equal to T2, whatever. But it's not the best 3 address code. You can write the best 3 address code later on. And static single assignment, SSA code. Here I can use something else, or I can also write something else. Instead of reusing it, instead of creating new variable, I can do one thing. B star C, after that B and C are over, I can store in B. Later on I am not using B and C here. And here A plus T1, A plus B I can write. Again after this A and B are useless, so I can use just A. This is enough. This is enough. Right? I can also use just 3 variables instead of 5 variables, right? But this is the best 3 address code, optimized one. SSA code is similar to that, but here this is SSA code. This is not SSA code. Why? Quick. Why? Because here B already has a meaning. You are again writing something into B, means you are giving new definition into the B. So this should not happen. Here every variable has a single definition. Every variable has a single definition or single assignment. Single definition, also called as assignment, also called as meaning. Come on guys. So every variable should have a single meaning. Multiple meanings you can't give to the same variable in the same code. So that is the reason this is SSA code, this is not SSA code, because we got second meaning here. So this is not SSA code. Everybody, SSA code is also 3 address code where Sumit, your compiler nahi padha raha hu yaar, I am just making you revision, Sumit. All right. Sumit. या सिर्फ सुमित को चाहिए क्या? ओके, इनको ये कुछ चाहिए था, कोड ऑप्टिमाइजेशन को हटा देते आज, मुझे क्या दिक्कत है यार, इनको ये पढ़ा लेते हैं. मेनली यू हैव ट्रिपल नोटेशन एंड क्वाड्रपल, इनडायरेक्ट जरूरत ही नहीं है, ट्रिपल नोटेशन एंड क्वाड्रपल. ये पढ़ाना क्या आपको? Quadruple notation. Good. If you have any statement like x is equal to a plus b and y is equal to x star c, how do you define this using triple notation? Triple notation, you will have, let's say, three things to remember. One is operator, other are left operand, right operand. Where you don't have x nothing but your address. Let's say 1000 is an address. And next, multiplication is operation. X is nothing but address, so you are going to use 1000 here, because 1000 is nothing but a plus b only, and c is there. And y we are not going to use, we are going to represent as address. Let's say 1010. Everybody? Yeah. Yeah. Quadruple. What is quadruple you require? I'm not interested to teach this at all, just I'm teaching because you are asking it. Okay, you have address and you are going to represent plus a, b, left operand, right operand if it is binary, and then result. Result is in x. And now you may have, let's say 1020, x you will have, and star first, and x, c and y. You are going to represent a separate field for storing the result, but here you don't have storing the result. Every time you want a plus b, you need to come and compute here. So both have advantages and disadvantages. Yeah, and simple things, Sweta. If you have anything, you can go and learn indirect triple. Just instead of using 1000 directly, you are going to use indirect address of this 1000. 1000 you keep somewhere else and you can use that address. 2000 or 3000 you use instead of 1000. This address is going to be indirect. Instead of using 1000, you can use indirect now. Alright. Don't worry about indirect. Just like a pointer. It's just like a pointer. Right. Don't make it boring, guys. Okay, now we need to focus on these two things. The one kind of question it is, finding minimum variables, which is one of the difficult point here. And second, finding additional variables. Sometimes additional temporary variables might be required. Do you need anything? And they might ask finding total number of variables which are required minimum. Both are minimum only. Do you require additional minimum temporary variables? Yeah. Among them, both require the same concept. Both require same concept. At the end, calculation is different. That's all. Look at example. X is equal to a plus b minus a into c. Okay, just wait, guys. Let me take another slide. Okay, I need to go a little bit slowly now. X is equal to a plus b minus a plus c multiply with d. There is some example. Now look at, first thing is, remember when you are writing 3 address code, reordering. If possible, try to do reordering. Second, simplifications, algebraic simplifications. You need to focus at any cost because they don't have a particular algorithms, only depends on the example. This reordering or simplifications will help you. When you look at this, minus a plus a, you can cancel it. So this can be similar to x is equal to b plus c star d. How did you get cancellation a minus a? So if it is addition, I can do commutative. So plus a can go this side. So plus a minus k, I can cancel it without changing the logic. Yes or no? Now this is important. Now you need to calculate c star d first, then b plus c star d, and the result no need to store in X, you can store in any variable. So what I am going to do, C star D, I will calculate, I will put this in just C only because C and D are free after that. So I am going to put into C. Then B plus C, and everybody is free, you can reuse B, C or D is your choice. Over. Just total, we require 3 variables in 3 address code. But in SSA code, very simple. Once you get this, B, C, D, 3 variables must at any cost because they are coming from out, and additionally 2 instructions. So you might get C1 and C2 here when you are writing SSA code. So additionally you require how many variables? 2 variables. So total you require 5 variables in SSA code. Without writing SSA code, you can say this is going to be C1, this is going to be C2. Yeah, plus 2, that is the shortcut we have. Clear? Yeah. So let's move to the control flow graph. Yeah, can you revise yourself control flow graph? I'm sorry guys, I thought I can complete in 3 hours, but TOC I made it complete. In compiler there are so many difficult concepts are there. Basic blocks, try to learn. Basic block nothing but it is a set of instructions like I1, I2 and so on. The execution must be sequential and the control only enters in the beginning and control only leaves from the end. The control never enters in the middle of the block and control never leaves from the middle of the block. Right? So basic block is set of instructions which should be executed in a sequential manner, and the control enters only at I1, controls only leaves at last statement whoever is there. Let's say I3. After executing I3 only the control leaves. So this is the basic block, and a whole program can be converted into set of basic blocks and set of controls. So here we will have basic blocks and controls. In the exam they might ask 2 questions. Question 1, number of basic blocks, and question 2, number of nodes and edges. So be ready for these 2 kinds of questions, number of basic blocks and number of nodes and edges. I'm sorry, I'm going to take a few minutes more. Yeah. Just to complete the code optimization, I'm not going to teach code optimization because this is not the compiler class, it is just revision of compiler. Okay, in code optimization, I'll help you techniques that you have without analysis, the techniques. Like you have a constant folding. This will help you when you have like 2 into 3. You can replace with 6. That's called as constant folding. Copy propagation. Suppose you have x is equal to 2 and y is equal to x plus a. Here you can replace this one with y is equal to 2 plus a. Because now you can propagate the 2 wherever you see the x. It's called as copy constant propagation. Yes. 3. Yeah. Use for local or global. Study yourself, guys. Yeah. Leaders of the basic block you can compute. Yeah. Deepthi, I need to spend at least 10 to 15 minutes for that. I can't revise it. Okay. Strength reduction. If you have something x is equal to x into 2 or y into 2, whatever, you can replace with cheaper one. This is a costlier basically. Costlier instruction you can replace with x is equal to x left shift by 1 bit, or you can write or you can replace with x is equal to x plus x. Yeah. So there are so many cheaper ones. You can replace costlier with cheaper. That's called as strength reduction. That's called as strength reduction. Yeah. Yeah. If you want, if you stay till the end, I may explain about basic blocks, but wait for that. Yeah. Fourth example is algebraic simplification. Just now we have seen cancellations or associative commutative we can apply. Algebraic simplification. I said if you have x is equal to a plus b minus b, you can cancel it. You can just say x is equal to a. Fifth one, dead code elimination. Yeah, please study it. As we have already crossed 3 hours, so I'm just making you the reminding of examples. Dead code eliminations are 2 examples. One is unreachable code, other one is useless. There are 2 kinds of code. Of course, both are useless, but unreachable code is definitely useless, but useless code no need to be unreachable, need not be unreachable. Let's look at what is unreachable and what is useless code. Unreachable, of course you know it, very famous example. If 1, write something statement 1, else you write statement 2, and this is unreachable code because it is always true, right? Come on guys, please respond. So you can replace this code with just S1 by doing so many optimizations. Even if also you can, because it's a costlier than this one, so you can replace this costlier with cheaper one. Yes, everybody, this is unreachable. And another one is useless. Of course, this is also useless. Okay, useless code is like x is equal to 2 and you are saying that y is equal to plus a. Now you are just writing print y. Tell me now, it's just a program, pseudocode, x is equal to, did you use anywhere? So this is also dead code, which comes under dead code. If you use optimization, we say x is not live. If you are using data flow analysis, you will know that x is not going to be live, because live variable said when we compute, the x is not visible. That means this statement is dead. Everybody, so I hope you remember this concept. I'm just reminding that in this statement, here you can, if you compute live variable set, x is not live there because nobody using x in the future. That means x is not in the live set, so the statement is going to be dead code. Yeah. Yes, a and y are, y is not live. Only a is live here because y is live here. Okay. Y is not, yeah, y is live there, right? Okay. Now we have some more optimizations like a loop optimizations. I'm not explaining, sorry guys. Loop optimizations, I'll just tell you the names that you need to study. Loop optimizations. One, you study about code motion, how to move the code out of the loop when it is not going to, it's basically loop invariant. You can move the loop invariant code. Loop invariant code you can move outside the loop. And second, you can learn induction variable elimination. If there are two variables in the loops which are doing the same thing, you can replace one variable with other so that you can save the number of variables. Induction variable eliminations. That's 2. And loop merging, you can merge 2 loops. You can merge 2 loops. And loop unrolling, you can save the time of execution. And these are the things you might require to learn for the basic things. Yeah, common sub-expression elimination, right? You also have other point. Let's say this is the 6th or 7th. Five over dead code elimination. This is the 6th and 7th one. Common sub-expression elimination. Oh, yeah, hundreds of techniques are there, guys. These are very basic techniques I am explaining. You can use the DAG or you can use data flow analysis for this. You can use either DAG or you can use data flow analysis. Okay. Yeah, this is what I can tell you right now. Priya, what is once again? Yeah. Anything that I'm not explaining, it's just a division, right? Code motion, do you need an example? You can take it. It's already more than 3 hours. Because of no water I have right now, you know, I'll just leave for you how to, you have very good examples. On YouTube, you can find out. Okay. Let me give you last final tip for you. Data flow analysis. What you require to learn here. Very sorry for this. Data flow analysis. Here you may require to learn live variable analysis. Is also called as basically backward. In the exam they may ask live variable analysis is a backward or forward. Backward analysis. And there is another one, reaching definitions. Is a forward analysis. There is another one, available expressions computation. Available expressions also forward analysis. So in case if they ask match the following groups, please answer these 3 points. Yes, everybody? Yeah. How many of you need the control flow graph? Basic blocks, Deepti? It's not gonna be easy in the revision, but anyhow, I'll help you. How many of you need the control flow graph? Yeah. I'm sorry guys, because of time over, and I can help you this much. If anybody need more, I can help you little bit of 5 minutes time. Yeah. So we have 3 days left. I hope this session, I hope this session is helping you. But few special topics like undesirability, code optimization cannot be done in a revision in less time, because you need to follow them using definitions. Yeah, basic block, Deepti, if you are not aware of this, please learn from the basics. Of course, I can help you by taking one example. That's all, one example only, not much. Okay. Suppose you have written a program. Okay, there is some code here I'm writing. Now first you should know how to draw the, you can leave if you are understood this concept. I think this is all completely over. Only somebody is asking basic blocks, so I'm explaining. So first you should know how to write the 3 address code. So suppose you have to check here, if x greater than 10 you will enter. Suppose if x less than or equal 10, then you have to jump to this statement. You have to jump to this statement. So go to something like x, 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 so that is print y. Opposite I am writing there, that's fine. If it is x greater than 10, definitely you will come here, y is equal to y minus 1 and x is equal to y minus b, and print x, and then after that you just write go to. You need to come back, right? You need to come back to this, go to let's say triple y, and here you write this triple y address. And this is first you need to understand how to write the 3 address code. Once you write the 3 address code, now you just take the control for graph. How do you do that? Let me help you. These concepts cannot be done in the revision, only because of you I am doing. You will enter, go to triple x means you will go to this one, or you will enter this side, and triple y it means this one. Now looking at this, I can make control for graph. Look at here. So how do I make? If x less than or equal 10 is in one block, because I can't add this one here, this one here. Of course GOAT is fine, that's the edge. I can't add y is equal to y minus 1 because the control is not always coming to here. So we have 2 controls. One control enters into y is equal to y minus 1 block, and other control enters into print y. So other control enters into print y, but print y is alone, just it's fine. And y is equal to y minus 1. After that you need to execute always y minus b, and then print x, and go to means we need to go to triple y, that is this one. Go to statements are nothing but just edges. Go to nothing but just jumps. Every edge you can call it as a go to or jump, unconditional or conditional jump, doesn't matter. So all the controls I have created, all the edges that I have created are nothing but go tos or jumps only. So this is how you draw a control for graph. Look at, if I enter at y is equal to y minus 1, I only leave after print x. So all these 3 statements are sequentially executed, and this is called as basic block. It is nothing but set of instructions, and where the control enters at the beginning and leaves after executing the last statement. Here y is equal to y minus 1 called as a leader. Here this statement is called as a leader. Here print y. What is the leader? A first statement of every basic block is called as a leader. First statement every basic block is called as a leader. To find them, you should understand the control flow. If there is a formula, you could have understood already that formula. Only the concept understanding can help you, because you need to understand the definition of the basic block. This is the basic block. There are total 3 basic blocks for this code. So I can say 3 basic blocks for the given program. If they ask nodes and edges, you need to give the start and end, and you will get additional nodes and edges here. Everybody? Yes. Yeah, thank you so much for joining today's session. Of course, let me complete this session. Yeah, you have number of days left for GATE is just 3 days, and today I have helped to revise the compiler maximum possibility, whatever it is. But I didn't tell you 100% I will deliver. In 3 hours, nobody in the world can teach you compiler, right? 100%. Even I'm helping you to make you best revision that is possible for you. Yeah. All right. And we have so many good experts on GradeUp, and it's me and Murali Krishna sir, Satyanarayan sir, and Ankit sir, Navnit and Anshul. So these are the people who are going to help you on GradeUp, and you will enjoy a lot when you are joining GradeUp, because you can see the GradeUp started from here and it's moving to the height. And if you want to be here, and please join the GradeUp and show your face, and you can have green card to attempt online mock test and designed by the toppers and based on latest exam pattern. And you have so many benefits on GradeUp courses, like structured live courses, and we have entire batch. We don't teach individually, we teach like a we teach like a team, so that you will get the best feeling between the educators and between the students, and you can get you can get a lot of interesting concepts combinedly, because we are going to help you in interactive doubt sessions, and also full syllabus is covered, that is guaranteed from our educators. And if you have any doubt, you can ask anytime. And this is what we have, and the Grade Up Super, and this is going to give you unlimited access to all structured live courses, and also unlimited time you can access to mock test. You can practice as many as possible. I don't think more than 100, more than 100 when Grade Up platform is providing you, and to complete them you need whole 1 year. So this platform is enough to practice a mock test and to attend the courses. And download the Grade Up app and start learning from today onwards. If you have not started joining, or if you have not started your journey on Grade Up, and this is the day there you can start. Yeah, thank you very much. Yeah, Chaudhary, this is not the right time to talk about the PSUs. We will have a separate session for that. Yeah, I can't deviate. All right. Yeah, tomorrow, yes, revision, not revision. Tomorrow you have a 9 a.m. Tomorrow you have 9 a.m. 50 questions from all subjects. I'm aiming that these questions will give you at least 50 plus concepts that can help you to get 50 plus marks in coming exam. Yeah, Naveen Sharma. आप भी थे ना, मैं भी नहीं. Tomorrow we have one more session at 5 p.m. C programming revision, guys. Yeah, C programming revision. All right. But live class is showing 9 p.m. not 9 a.m. Okay, let me check that. I will cross check it. If it is 9 p.m. I will let you know. Right? Yeah, you can visit our YouTube channel and look at the timings, and we will plan accordingly. If it is 9 p.m. then I'll let you know. All right. Thank you so much. If you have any doubt, please join me tomorrow, and we will discuss about the coming plans. And tomorrow we have 2 important sessions, and day after tomorrow I will be taking discrete mathematics class. And thank you so much for joining today's session. Please show me your response after this class. How much it is revised today? Have you revised almost every concept except code optimization? Yes, I'm not able to help now. Yeah, thank you so much. Yeah. All right. Thank you everyone. Ruksha, after the exam, Rona, Abhinay. Yeah, man, thank you so much. Yeah, I will try, Shubham, because I need to ask the people who can convert this into PDF. I'll ask them to convert, and I will share that, possibly. Yeah. Fine, Shubham. Yeah, please utilize the time, and if you have any kind of doubts, please install the Grade Up app. We are there to help you this last few days to clear your doubts, and tag us, and so that we can help you a little bit understanding the revision and concepts, guys. Thank you so much. Bye bye. Take care. See you tomorrow morning 9 a.m. possibly. Bye bye. Yeah, thank you.